All right, so good morning. I'll go ahead and share the screen here. You should be able to see it okay now. And we'll pick up where we left off. So we were talking a bit about some of these concepts. We've gone over some points and point groups and things that we've learned, some editing techniques, some drawing tools like drawing 2D and 3D polylines, drawing various features. We talked about layering and where things go on a particular layer, and then you can set a color and a line type and a line weight, um, either independently or assign it as by layer, and it will take on the characteristics of the layer definition. So then we're going to next take a look at some surface modeling, terrain modeling. And basically, what it is that we're trying to do is stitch together a bunch of little triangular patches that represent some kind of a surface. Now, it doesn't have to be just irregular ground. It often is in terms of our initial survey work and our existing grades. But our proposed grades, we could have flat, dead level, flat building pads, or things on slopes or parking lots and concrete steps and you name it. Anything that we can build, we can represent as a surface. And so the computer uses an algorithm, or the process of computing and creating terrain surfaces is done using a number of different algorithms, but the one that's most widely used in civil engineering and surveying is a process called Delaunay's criteria. Is a French mathematician back in the either the late 1800s, early 1900s, I forget when. Anyway, came up with a mathematical process to look at a bunch of individual points. And it realized too that when you model a surface, when we do it, we're modeling elevations, but you can actually model anything. You can model age distributions, you can model temperature variations, you can model any kind of thing that has varying data, that has, points that have a specific XY location, and then some piece of information about that location that could be what you model in terms of a surface. So you may have seen, particularly those of you who do excavation work, you may be used to seeing cut and fill contour maps, or what we call isopacks, which are contour maps that contour the amount of cut and fill. So basically, it's contouring a difference between two surfaces. So in that case, it's not really an elevation that you're seeing a contour for, but rather an amount of cut or an amount of fill. So for us, we're just doing an amount of elevation or amount of height, and we represent those with contour lines, which are lines that represent a single planar elevation. Now, in the old days, we used to sit down with a pencil and hand draw those things, and then even in the and even in today's day and age, when we're doing our design, a lot of designers still design by drawing finished contours. They know what the elevation is that they want things to be, so they'll draw a contour line to represent that. And yet, when you consider a collection of contour lines, the only information that that gives us is the information along where that line lies on the surface. And it doesn't tell you anything about what goes on in between. The assumption is that it just changes in a continuous linear fashion from one contour line to the next contour line adjacent to it. Now, we can supplement that with some spot elevations and things like that. So there we can go. But imagine if you had to try to figure that out and try to draw that every time you were trying to design something or to change something, or if you're trying to figure out what the ground looks like. Uh, so, so what we do then as part of our process is we gather up all of that point information with elevations and we throw it in the computer and say, all right, I want you to analyze all these points and then tell me what that is going to look like as a surface when you put together all of these little triangular patches. And those triangles, by the way, are irregularly shaped. Therefore, it's typically referred to as a TIN or a TIN, which stands for Triangulated Irregular Network, which means a network of irregularly shaped triangles. But anyway, how the algorithm works is the computer takes a look at a collection of points. And here's an example of 4 points. It'll look at a given point, and then it looks all the way around itself, 360 degrees, and it looks for other points, either, either discrete points or vertices in three-dimensional line work. So uh, it looks at those point locations, and if there's nothing between where it is and where that point location is that it finds, it goes ahead and constructs an edge of a triangle that it's working on. Okay, so if I'm sitting down here at this lower right-hand point of 100 elevation, and I look up and I see this 110 to my left, and there's nothing in between me there, no line that's breaking that line of sight, then I'll go ahead and make an edge of my triangle up to that point. And then that's done. Then I'll look around again and I'll find another point. Maybe I see this 110 over here at the top next. And so I'll go ahead and make an edge up there. Now, once I've defined those two edges, then it finishes and closes off the other edge to make a triangle. So it just needs 3 points to participate in a triangle. It makes the triangle. And so now as this point down here in the lower right with elevation 100 is still looking around itself for other things to connect to make other triangles, it can no longer look up here across and see this other point in the upper left because this edge of this triangle has been formed and it's in the way. It is breaking that line of sight, okay? And it functions therefore as a break line. All right, so that's where we get that term. You might have heard the term, break lines or lines along breaks in grade. Well, that doesn't necessarily explain things very well, but if you keep in mind what a break line really is a break line is really nothing more than an edge on the surface. So, and in fact, here's our little rule of thumb here is the way you're going to use break lines is right here. Oh, that's interesting. Let's see. Yeah, that's what I thought. They don't treat them the same as we do. They're talking about breaking in. So break lines really nothing more than just edges on the surface you're trying to model. And if it's an edge on the ground, then you need to make it an edge in the data set. And what that means is that we need to draw those lines in before we tell the computer to go ahead and use Delaunay's criteria and start to make the surface, because it can create triangles erroneously. It can decide, it sees a point somewhere and decides to connect to it. And when it does that, the assumption in the model then becomes that the elevation changes from the point that it's sitting on to the point that it's looking at in a straight line. It doesn't go up and down between those. So if the ground actually does change elevation and does not change in that smooth linear fashion, then you need a line to interrupt that line of sight. And here's my favorite little uh, descriptor of how this happens. So if I'm out there surveying this edge of the street and the curb line, and I get my surveying instrument, and I shoot these points, A, B, C, D, E, F, G, and H, okay? So when I start to make triangles, if I'm sitting on point A and I'm looking around for other points around me to make a triangle edge, I can look around and I can see point number B, and I can form an edge of a triangle up to B. Well, that's perfectly valid. That's fine. That's the way the ground does follow. I can also see point letter C, and so I would draw, do a little dash line here from A up to C as an edge, because I'm saying the elevation changes from point A to point C along a continuous smooth change along that surface. And in fact, that edge is also correct, because it just, it's a slanted surface, but it follows that surface. But what about if I'm sitting at A and I can see over here to point E? If I decide to form a triangle like that, or even up to G, so if I go from A up to E, then I'm telling the model that the elevation follows that straight line, and it doesn't. It goes down to the flow line and then climbs back up the face of the curve to the E. So I need something in between points A and E before I let the computer start to model, and that's something that's called a break line. And so we would draw these break lines. And the way that happens in the field is we start surveying things and we give them descriptions, like points A and B might say EOP for edge of pavement. Points C and D might be, FL for flow line, or FC for face of curb. E and F would be TC for top of curb. G and H would be BC for back of curb. And then you go through before you start to model and you connect all of those things together that have those same descriptions, as long as they're representing a straight edge on the ground. And there are a lot of automated techniques to allow us to do that. So we don't have to, spend 2 days playing connect the dots. The computer can look at those descriptions and the order that they were measured out in the field and can start drawing those for us. So once we do that and we draw those three-dimensional lines that connect all those points along those like features, then we can start to build the triangles. And so here's, some picture over here on page 21, that shows you what can happen if it doesn't do it correctly. See, if you don't draw the break lines in first, point A can see over here to point E, point C can see up here to point G, and it just, you know, misrepresents where that's, how that actually looks. Okay. But if you do draw in those edges, then you're forcing the triangles to form like they do over here on the picture on the right. The triangles form only along those planar surfaces, because, for instance, point A cannot see any other points other than C, B, and D. Now, just to answer your question, if it were to see over here to point D first before it saw between B and C, it could very possibly draw that long edge over there, but that's still valid because it's following along that planar surface. So, it could have a triangle that is A, B, D, and back to A, so that B and C doesn't form because there's now that line between A and D. That would be fine. But anyway, they generally tend to do this. Now, surveyors in practice for a lot of years before they really got proficient at building and creating and constructing these break lines, they would go out there and they would just survey a whole bunch of points. You'd get the back of curb, the top of curb, the face of curb, the edge of pavement, and they'd get them all together, all clustered up. And then they would go, 20 feet away and get another group. And they start, you know, trying to survey more and more and more and more points and cluster them together in hopes that the triangles will form in those clustered locations first. And that's not really a very, well, first of all, it's not efficient, but second of all, it's not even necessary to do it that way. As long as you know where these break lines are, you can interrupt that process with those break lines. But anyway, so Delaunay's criteria makes these triangles, and it does so by sitting, say, at a point, say at point A, it looks around, it can't see point E, but it can see points B, C, and D, and so it draws usually the nearest edges it will draw first. It's not necessarily the case. There's some mathematical stuff that's going on, and I don't know what that is, but it will create those two edges there, and then the creating of those two edges will create this third edge. So B doesn't even have to see over here to point C. As long as A has already formed this triangle, then that's already an edge for point B, and then the only thing it can see at that stage is D. So it would jump up there and start drawing that triangle. Okay, so it would be, you go up to D, and then it looks over here, and this edge is already there, so that's now two edges. So the back edge along the flow line would then form and make those triangles. But it does all that, and then it does some mathematical testing, like it goes to the centroid of each of these triangles, and it computes the distance to the nearest other triangular centroid, and it makes some determinations and some judgments on whether or not a triangle is valid, and can reject them for various mathematical reasons, none of which you need to understand or know. But that's why that you have to do this. If you are just surveying a bunch of points, your triangles could form like this, which again represents that ridge line of 110 feet elevation with fall off points to the left and right of 100-foot elevation, or depending on the order in which it selected those points and started to do the algorithm, those triangles with these same 4 points could just as easily have formed like this, which would invert that piece of ground. It would have the high points on the sides, and it would have a little valley floor across the bottom. So that's why if it is truly a valley, then we need to, excuse me, we need to connect up those points along the valley floor and call that a break line, so that we can prevent point 110 from looking over to point 110 in this direction. Okay. So that's the essential gist of everything that we do in this modeling process. And it talks about that right here. We call it a digital terrain model, a DTM. Sometimes you'll hear it referred to as a TIN or a TIN for triangulated irregular network. So we're going to use these break lines to be barriers that are going to keep a point from looking across and seeing points on other sides of that break line, and then constructing a triangle edge between where it is and those other non-related points. Okay. And we talk about that triangulation, but there's also other mathematical techniques such as gridding and Krieging. There's some statistical means and manipulations of that point data. Okay. And so here's what you need, of course. There's some data sources. You need that source of points or three-dimensional line work. So we're doing ground elevation. So we have point locations and edges, which are break lines. Now, Carlson, as opposed to other modeling software like Civil 3D and Open Roads and things like that, Carlson considers any three-dimensional or any object with elevation, even if it's zero, unless you throw a switch that says to ignore zeros, which is what we most often do. But Carlson considers any of that line work that is included in the data that you select to model the surface with, then it is, by its simple existence, it behaves as a break line. Other software applications, again, like Civil 3D and Open Roads, you have to tell it that, hey, I want to use this as a break line. Otherwise, it ignores it and just looks right through it and models past it. So it can be a problem. So that's another advantage to Carlson is you don't have to go around setting up things and telling it, hey, this is a brake line, this is a brake line, this is a brake line. Oh, don't worry about that one. That one's not a brake line. You just simply select it. And if it's got elevation, it's going to be used as a brake line. Okay. So we get that information from a number of places. You can get them from other digital files. You can get them from surveys. You can get them from, um, other mapping if recreate that mapping in your computer. And then once you have all that data and you make those into a surface, here's the biggest problem that most people run into is they'll hit the button that says triangulate and contour. So they're going to generate the files and the computer churns a little bit and then spits out, the results and says, okay, here it is, I'm done. Now we're looking at it in plan view all the time. You remember, you may have seen some surprises when we spun things up in 3D and looked at it because we can't tell that it has that elevation difference when we're looking straight down on it. So one of the biggest problems is we say, here, compute the surface. It comes back and doesn't give us any errors, and we go, oh, great, we're done. But we need to look at this stuff and see. We need to look at it in 3 dimensions. We need to, maybe cut some quick profiles, if you remember that tool that we looked at yesterday as we cut across some of those 3D lines. We need to look at things to see, to make sure that they represent what we know that surface to look like or what we intended to look like. So here's, an example of looking at elevations. We might have a printed list of X, Y, and Z elevation, X, Y, and Z coordinate positions. And we could scan that list. And if we saw several that said 0, or if we saw some that said, 25,362, we would know that there's something wrong with that data. If we look here, this is a picture of a little file, much like the one we looked at yesterday at the end of the day, that the photogrammetrist had put together, and they did that by creating those brake lines. So they go into their viewers and they're looking at their 3D model, the photographic 3D model, and they're putting a little dot on the ground and they're drawing these things and they're keeping that dot right on the ground as they draw it. And then all the spot elevations, they're just dropping the dot, hitting the ground and recording the elevation of where the machine tells them that that elevation is. So that data looks okay in plan view, but it could be something like this, and you'll see this done a lot as well. You'll look at this information. We've spun it up in 3D, and this all looks good. There's the center of that stream, and it will be used as a brake line so that points on the bank over on one side can't jump across and look over here and say, connect a triangle edge and tell you that that's flat across there, because it's not. So that line is going to serve as a brake line. Same thing as these road edges. As they're going up here, we're keeping something on this side from looking across and finding something on the other side. But plenty of times you'll see, all this brake line data gets provided, but then they'll draw the road edges maybe and the stream edge down at 0 elevation. And so that means that they're not going to be in this model like you see on the left. And so triangles can form invalidly across those divides. Okay. So, and it doesn't always do that. That's why it's hard to spot these as errors. Because we may see a resulting set of contours, and that doesn't really tell us much because they're right most of the time and in most of the places, but where it creates those invalid triangles, it makes some, irregularities in our surface, like little stair steps instead of smooth profiles. Um, so we'll see how that happens when we work on these models. Okay, so if we were to get data like over here on the right, what we would need to do is take those road edges and that stream center line and give them elevations all the way along their length so that they lie on the ground like you see on the left-hand side. And there's some techniques that help us do that. But usually if I'm getting that from the photogrammetrist and they sent me that, I would send it right back and tell them to fix it. Okay. So again, that key rule, everything that you are going to use as your source, all have to be at the same elevation. And the best way to evaluate that without looking at a chart full of numbers is just look at it in three-dimensional space. Okay, so we can see it very readily. Now, we have one other little consideration that's really nothing more than the same idea on the break lines, is when our data is masked in a generalized location, like all of this stuff vertically down the left edge and horizontally across the bottom edge, all of that data is there. It's good. You can see all the triangles have formed to create those features. But what about these long, skinny triangles up here in the corner? And why did they form? And they formed because when the computer is sitting on, say, this third point in from the edge, it's looking all around itself. Well, it finds this point, makes an edge. It finds this point, makes an edge. All that's good. It finds this point, makes an edge to make that triangle. It sees that point, makes that edge to make that triangle. But it also can see this edge way up here. And so it will draw in that triangle edge because we didn't put anything between it, between those 2 points and say, don't look past this. You've got to use that. So we need to think about this concept called a boundary so that we put an outer limit along where we want to model. And that serves the very same exact purpose as a break line does, is that it keeps those triangles from jumping across that open space. Now, as it happens, the way it works out is that those only form, and they're only a problem is if the mass of the data is in a concave configuration. In other words, if we were to tie a string around all of our data um, and pull it tight, it would leave a gap in here. So at this point, instead of coming in and over, if it went out this way and down, and we put a string around that and pulled it tight, it would wrap around nice and tight in there, so we wouldn't have to worry about those triangles in that case. It's only where it cuts in is where we get those. Similarly, in the file we looked at yesterday, right in here in this area, that's open space, and I've got points down here, I've got points up here, and I would expect to see those long, skinny triangles forming even all the way from way down here, going all the way up to here, and those would not be valid triangles. They're mathematically okay. That's, they connect the points at those same elevations, but the reality of that surface out there is when we form those triangles, we're telling the uh, the recipient of all this work and this data, we're telling them that, hey, these triangles exist out there like I've done them. And the truth is, we don't know anything about what exists out there. There could be a stream channel, there could be a little ridge line, a mountain, there could be a big hole in the ground. We just don't know. So those would be invalid triangles out there. And a lot of people just ignore them. They do them because they're not doing work out there, and they trim off the contour lines. And that's an okay approach. But it's simpler to just draw a boundary around it before you do the modeling. Okay. And so we're going to see how that works. And along the way, we'll learn how to use that 3D viewer because we're going to be doing it a lot. Okay. So let's pop in to our Carlson. By the way, did you guys get my email about uh, my that trim issue was apparently just caused by going through Zoom. Like after I quit the Zoom session, I did not even, I didn't restart Windows. I didn't do any of that kind of stuff. I just went right back to it. Um, and so I don't know, just one of those freaky things. All right, so let's open up our file. And if you had it open yesterday, this one called sample from T3 Global, and it should be in your list of recent files on your start page. If not, look in your folder that holds your data sets, and let's get that loaded up. Now, here's another technique here, or that is often used in photogrammetry and modeling. I'll illustrate it here. Just you don't have to follow this, but I'll illustrate it. I'm going to isolate a couple of things here. Um, Get a place where I know there's some. All right, let's do these. All right, so we already talked about these being those three-dimensional break lines, and they're there to help us build the model. But look what is underneath those. You see those down there? And those are all drawn at 0 elevation. They're drawn plan view, and they are exactly underneath, when I'm looking straight down on it, these up here that have the elevations. And this is quite often the case of how these are done. And the reason for that, and it's not going to be apparent here because they didn't do them here because they still made those as individual chorded segments around the curves. But the reason that's done most of the time when we are modeling is that if we have to draw something, or if we want to draw something and it's a true arc, it's a measurable arc, and we're going to put a label on it that says, hey, that's a 15-foot radius arc at this turn island or what have you. The only way we can do that is if that line work is two-dimensional, okay? Because to make it 3D, there's no such possibility as having a 3D arc. Arcs always have to lie in a plane defined by their two endpoints and a point somewhere along the arc. So, so they can't be changing, as they go up and down. So to model arcs, we break it down into little short segments and provide points along all those little vertices. Now, it can look like an arc when we're looking straight down on it, but that's why we often get these done as a double set of line work. You got those islands there, you've got these same islands here, and they're just right directly over top of them, but they have the elevations, okay? So we would typically not use those things on the bottom. We would only use the things with the elevations, and those things on the bottom would be left alone to do the mapping and to put radius dimensions on them. And they also, by the way, in AutoCAD at least, it's the only way to apply a line type, a line style to that line. If it's a 3D line, it always remains solid and continuous, just because of the way AutoCAD patterns lines. Now, other products like MicroStation, you can make a line style on a 3D line without any issue whatsoever. But So if you're wanting to draw those as, dashed lines to represent edge of a gravel road or something like that, you would have to do that as a two-dimensional line. It can be, it can still be at elevation. It can be like a contour line, but it has to be flat. It has to be planar. So that's one reason you're going to see those double sets of lines from time to time. So don't be surprised by it if you run into it. Just understand that they're there and that's why they're there. Okay. So I'm going to restore all those layers back and let's take a look at what it is that we're going to build our contours from. We've got all kinds of potential information. And again, it's all of this. We've got those individual points. If you remember, we saw those points throughout the data. And we got some of them, they're even labeled as spots. And we have these drawn contour lines. But now what you need to remember, those contour lines are the output from somebody else modeling the surface once ahead of us. And they modeled it with some other data. They're giving it to us so that we don't have to model it. If all we really want to see is where those drawn contours are, then we can just take that map and run with it. But if we're going to do any design on it, we need that surface. So if we were to try to build the surface out of the contours only, then it's going to cause us problems because the only thing that, if we're looking at these triangles as our source of data, the triangles are going to form, between these points, these big square, the square grips, not the little short ones that are the midpoints, but so it would go point to point and start looking around itself, and it would see, this point right here in the middle can look over here and see every point that it can see along this line until something gets in the way. Same thing about this direction. But a point back here on this line, as it's looking around, it can see all of these points, but it can't see any of these points over here because there is a line in between. So that case, the contour line itself is acting like a break line. And that's fine. That's where they're supposed to work. But here's a prime example right here of what a potential problem could be. If I'm using contours to model this surface, and sometimes that's all that somebody gives you. And so you just have to use it. But it's the worst form. It's like making a photocopy of a photocopy of a photocopy. You keep taking, blurrier and blurrier images of something because the results are missing. But if you look at these contour lines, what this contour line here in the middle is doing right here is it's saying, when I come up this contour line to this corner, I'm at that elevation, what is that, 1315. And then if I walk up here, I'm at 1315. And I keep coming over here, I'm at 1315. But if I walk straight from 1315 toward this other point right there, right in here, I should also still be at 1315 because the computer thinks, okay, I'm sitting here. I'm looking over here. I'm going to connect a straight line between 1315 and 1315. But is it 1315? And the answer is no. It's between 1314 and 1315. So it's a little bit lower. So the ground in here actually comes up here, drops down a little bit in elevation before it climbs back up. So I would need, technically in this particular case, to draw a line from this point all the way down here to this point and say, okay, you guys over here can't look across that line and see those other points. All right, so that would be a way of fixing that in that one little locality. Now we don't have enough hours in our life to do that for all those cases, but we do have some situations like this over here. Is if we have, let's look at this contour and this contour and this contour, which is along a road There's a sidewalk on it over here at this side. But let's see. Make this a little easier. We'll isolate these contours again. So if I'm looking at these contour lines right in here, if I were to, try to, let's look at one more up this way. So if I'm on this contour line here and I'm trying to build triangles, I'm going to come up to this point, sit right here, and I can look over here. That would be okay. I can look back this way. That would be okay. But I can also look straight across and see the point along itself. And that's not okay. That's going to make that triangle, it's actually, flat. It's at the same elevation as that contour line, but it shouldn't be. It should be lower right in here than it is over there. But if we don't draw that line, so we would have to draw a line connecting all the peaks of these contour lines all the way down as far as we need to take it until we run, get a little smoother. Like right in here's a great example between these two from here to here, because all of these points around in here can start forming triangles back and forth this way and making them flat, and they're not, because the ground is not the same elevation right here as it is on either side of those triangles that could form. So I would need to have a line from here down to here as a break line that says, all right, guys, on this side, you can't look across and see those over on the other side. Otherwise, it's going to form those flat triangles in there. And then if I were to look at a profile along that ditch, it's not going to go smoothly straight down from peak to peak to peak. It's going to go from peak out a flat distance, and then it's going to drop down and pick up this next peak, and it would go out till it ran off that triangle as a flat distance and then drop down and go to the next one. And so the results of all of that, if you're looking at it in profile view, looks like this. When it should look like this. Okay. Now, I want you to think about, let's change this color here a little bit so you can see it. Do you think about something here? When we model things, and if we don't have our break lines in place correctly to keep this stair-steppy thing from happening, then actually this would be right in there, would extend be up. It would be, on that line. So here's something that can happen. Wait a minute, let's see here. Actually, it would be more like this. Make these a little more exaggeratedly flat. Okay. So what happens is when we're modeling stuff, if we're going to try to go out there and now build that, let's say it's a curb line. This yellow line is the line we want to build because it's nice and smooth and the water flows down it. But if we just take this surface that we model incorrectly and try to build that, it's going to have those stair steps, and that would not do at all. And we really can't see this with the resulting contour lines because the contours that we create may not cross across one of these flat triangles, and it may look okay in plan view on a contour map. But here's where we also get into some problems with this data and not realizing it, is that, if I were to stop and look at it in profile or look at it in 3D, I would definitely see the problem. But if I don't do that, And one of the things that we do, and this is often used for quick types of things like computing earthwork volumes to build something. The volume comparisons tend to work out okay. They tend to work out to be correct because the amount of overflow or the amount that indicates too much is going to be up in these upper peaks, but they get balanced out by the amount that looks to be too little in these lower peaks. So across the site, if we got those modeled like that and they're all done incorrectly, we're going to get closer toward the average value of that when we're looking at volumes and quantities. And so they're going to be okay. And so that's a good argument that says if you're just putting this together for a quick estimate, you don't need to worry so much about going through and putting all these break lines in the data. But if you're doing it so that you can actually build it and you need exact, proper, and precise elevation data, then you need to put the break lines in. Okay. So, all right, that's about enough of that to hurt our brains with. Let's take a look at what happens when we model these things. We'll take a look at the surface and see why it's going to be a problem. Let's do this. Let's say we've gotten a file from our surveyors and they give us this contour map, and that's all they gave us. We're just the contours. So we need to build an existing ground so that we can design on top of it and compute our construction volumes. So take your file that you've got here and let's isolate some layers. So let's go to the view menu and choose isolate layers. And it's about midway down in the bottom section of the menu. And it's going to prompt you to select layers. We just need one on each layer. So I'm going to click once on one of these index layers. I'll get the label also. I don't know if it's the same layer or not. And I'm going to click one of the intermediate layers, but then also go over to either the pond side on the right or this platform and get one each of those dashed lines, one of the yellow ones, one of the green ones, because those are the obscured contours. And so now here's our contour map with the only elevation that the surveyors gave us was these contours, and this might be what we had to do. And so we're going to build a surface out of this and see what the results are. Okay, so let's talk about that tool. And that is on our surface menu, and it's called triangulate and contour. It's also a typed command called TRI. Oh, by the way, let me give you another quick helpful learning tip. When you see a menu, or you look at these commands in the menu, and you see that some of them have icons to the left of them and some of them don't, like this volumes by layers, there's no icon to the left of it, but two grid surface volumes has it. Same things when we do these pull rights, one has it, one doesn't. What that means and what that's telling you is that if it has an icon, that's telling you that that lives on a toolbar somewhere. It doesn't tell you which toolbar, just that it is on a toolbar. So if you find the toolbar and you want to use that as a quicker means of doing it, then that can be helpful. For instance, I go to the edit menu and polyline utilities, remove polyline, which does not mean erase the polyline. It means these are commands that help you remove parts of polylines like segments and vertex. Now I use this command all the time, remove polyline vertex. So if I were to always pull that from the menu, I'm clicking edit, polyline utilities, remove polyline, and then finally I get to the tool. I can also look down on the status bar at the bottom, and most commands, it's not universal, but most of them say things like, it gives you a little bit about what the command will do. Like this one says, removes the user specified vertex from a polyline, colon, RMVERTEX. And what that means is that's the typed name of the command. So if you wanted to type the command, after you've gotten used to what the command is all the time, you can type RMVERTEX at the command line and hit enter, and that does the exact same thing. However, I see that there is an icon to the left of it. Well, that's helpful. I know it's on a toolbar somewhere. And the toolbar that it's on, if we want to look at all of these different available toolbars under settings at toolbar, I'm sorry, not the toolbar manager, but the toolbar setup, there are a list of all of the available toolbars. And we can scroll this thing down and check on the ones that we want to have on, and then we can position them and dock them on the top, left, and right, bottom, etc. So that is I might come down here, my first thing, maybe it's on the edit toolbar. So if I turn the edit toolbar on, where did it put it? Probably. Yeah, right up there. So you see, you can grab it by that little dotted strip, and that's the edge. It'll also, if you hover over it, it tells you the name of the toolbar, and you can grab the corners and reconfigure it, however you want to do it. So that has commands like erase by closed polyline that we did yesterday. There's one, erase outside. There's scale, pivot point, align, extend, break, select by filter. Okay, so nothing that I really need to keep on a toolbar. So it wasn't on the edit menu, or edit toolbar, but it does live on. Again, ask yourself what it is you're trying to do. That remove polyline vertex. Well, I keep looking down here at some of these and I see that, okay, there's a polylines toolbar. And that's where it is up here, this polylines toolbar. And it has this command on it. It's got extend by distance, boundary polyline, join nearest, and then all the way over here. And there's a little picture that is very representative. Remove polyline vertex, shows a pencil eraser hovering over top of a red dot on a polyline. That's the vertex. So by that same functionality, the one next to it shows a pencil eraser hovering over a red segment of a polyline. So it will actually cut out the piece between vertices that you click on, making two polylines out of what you just had. So that can help you get to learn these tools and put them in reachable locations, if you just remember that about the icons. But one last thing about the icon, or about the toolbars, is when you're looking at these, don't forget this at the top, because you have 5 sets, at least I do, of different icons. Some from Carlson, some when you're dealing with Carlson using a MicroStation file instead of AutoCAD files, some if you're using the old C&G survey system, which we're not, and these are ones from IntelliCAD. Okay, and then IntelliCAD MicroStation, but IntelliCAD has its own set of toolbars, and some of them are the very same. Like there's a layers, there's a modify, there's layer tools and inquiry, and Carlson has its own as well. You just come down here and see, sorry, Carlson. Let me click in here now. If you look at inquiry is also in here. See, I've used the Carlson's inquiry, but not IntelliCAD's. There's layers, and the layers toolbar has some other commands on it. They're not all from this view menu down here. There's also some things from edit, erase, erase by layer. That's on the layer toolbar. Okay, so there's no real way to find out what toolbar it's on other than um, trying to figure it out by its functionality and then turning the toolbar on to see if it's there. So this command right here that I'm pointing at, my mouse is pointing to, and it says erase by layer, an extremely handy tool because we don't have to, isolate a layer and select everything on it. We can just run that command, tell it the layer to use, and it takes everything on that layer out, or the things that you select on that layer. All right, so just keep those little things in mind as you're learning it. And if you are a ribbon interface user, that's also quite helpful. Um, and they tend to be grouped more in terms of functionality than the menus are and the toolbars are. But again, I don't like to use it because it takes up so much vertical space. But in any case, here we go. Let's run our command on the surface menu called triangulate and contour. So I pull that down as the very first command. Now what we have here are 4 tabs: triangulate, contour, labels, and selection. And we're going to do things like, let's click on, say, labels tab. And yours might be all grayed out like that. That's fine. Go back to the contour tab and click on to draw the contours. And then the labels will be lit up. But here's where you set things like what layer to use, what text style, whether or not to label, the indexes only, or whether to hide underneath the label, etc. And you get all those things like you like them. Notice there's that load settings and save settings button. So you could set that, maybe you've got a certain set of layers you have to use for a certain client, then you save and load to bring all that stuff back. Okay. And also, like, maybe you're doing so here's a 1 foot contour interval, but maybe you're in steep terrain, you're doing a 5 foot contour interval. So you can call one of these, 1 foot, the other one 5 foot, etc. with that load and save. But let's take a look at what these tabs are going to do for us. Let's look at the selection tab first, the far right. And this is a means of telling the computer what to use, telling this command what to use to model this surface. And if nothing is checked, then that means consider everything that I select and work with it. If, however, I say specify options, and I'll say I only want to use Carlson points and CAD points, like no line work. So I could turn those on and off and it would ignore those. Even if I selected them, it would not use them. So it's a nice way to sort of tone things down if you need to do that. There's also a way that if you used another file that you didn't want to draw into your drawing, it'll just go out there and open up another file, read the data, and use that data. Now you also see something else, since most of you folks are fairly new to CAD. There's a thing called inserts. And an insert is one of 2 different things. It can be a block, and it has an insertion point, or in other words, it's home base. That's the point that would be used to place those blocks somewhere in the drawing. Remember, blocks are just like little mini drawings of something that you don't have to keep redrawing that stuff over and over again. You define it once and then use it as a single named block. The other is text. Text also has an insertion point, and that's the point around which it moves and how it's justified, either left top, left bottom, right top, middle, all of those different locations around the text can have that location defined, and that becomes its insert. Now, the reason they're giving you this option of using an insert to calculate a surface is because sometimes you'll get a file that has a little block that is a, like a spot elevation marker, or maybe it's a piece of text where all of the text has, the elevation, the numbers for the elevation written in the text, and wherever its insertion point is will be the point that it's going to use, regardless of what the text says. But that allows you to go out and use those, even though there may not be any point data there. It will turn that into point data if you turn that on. Okay. But for our purposes and for 99% of your work, we're going to uncheck that. We're not going to use those for anything. So from time to time, always look at that selection box to make sure you don't have something being filtered out that you want to use. Okay. Now, let's go next to the second tab, which is the contour tab. And this is whether or not you want to draw the contours. Because remember, the contours are just the output. It's the computer figuring out where the contour lines are going to cross this mass of triangles that it's going to create and put them in the drawing for you. And if you uncheck that, everything goes gray, as well as on the labels tab, it's completely inaccessible. I can't even turn it on because there's no contour to label. So back to the contour tab, if I say draw the contours, as a result of this triangulation calculation, it's basically combining a couple of commands. I say, go ahead and contour that. And you can choose to contour by a contour interval or a specific elevation. Now, I use this one from time to time, like if I want to show an outline of, the water level elevation, or the limits of flooding or something like that. So you would say contour and elevation, and then you would come over here on the right where it says contour elevation. You would give it whatever elevation you want it to contour. But most of the time, we're going to contour by interval. And so now elevation turns to interval. And if I want 1 foot contours, I would put 1 in there. If I want 5 foot contours, I'd put 5 in there. And notice what happens when you tab out of that field. 5 knows that the index needs to be 25 because there's 1 index and 4 intermediates. Okay. So 1s and 5s, 2s and 10s, 5s and 25s. You'll hear old mappers talk about that. Hey, give me a contour map. I need 2s and 10s, and that's just what they mean. They want a 2-foot interval, and the indexes are on every 10 feet, becomes a heavier contour line. So now, up at the top is the layer name. You can either pick an existing one or have one there, and if it's not existing, it'll build it for you. And if you uncheck draw index contours, it just puts all the contours on this layer and makes them all the same. But if you want to differentiate them, you can do it like this. Give it a different layer name, and you give it this number actually calculates from this number. Okay, so, and then you can give it a line width, although I like to define the layer to have a line weight instead of creating a width defined polyline. And the other things are pretty self-explanatory, the contour length. And these outlier reduction filters and meander reduction filters, that's just some little massaging that it's going to do to the line, to the drawn polyline, reducing the number of vertices. Okay, so it's going to, help the appearance of those lines a little bit, just like down below here where it says contour smoothing, either no smoothing or Bezier smoothing. Okay, so Bezier means it's going to make a series of Bezier curves, and you can do some further, surface subdivision of of those triangle edges, etc. And so the Bezier smoothing, now you have a factor over here that you control the amount of smoothing. Notice that if you're all the way to the left, the little preview shows you that there's pretty sharp angled contours. Whereas if you go all the way to the right, they're nice and round, but look what you run the risk of doing is when it rounds out the contours, if you've got close contours, they could actually overlap. And that's not something that is actually allowed in contour mapping. You can't cross another contour. So that's there, and that helps you make them look smoother. But keep in mind, if the contours would be nice and jagged and sharp like this as a result of no smoothing, simply turning the smoothing on does not smooth out the surface, okay? Because the surface remains the surface. It has its own triangles, and the triangles are not changing. And there's a little example of this. Let's see if I can find it to show you. Um, well, it was, I used to write a column in American Surveyor magazine called Model Behavior. And we talked about surface modeling and all that. And there was an example I gave of where these contours that came across the parking lot were, real sharp in the corner. They had a real big crease in them because the parking lot was made out of two giant triangles, which were mathematically correct. It read the elevations at the corners, but I really wanted a nice, smooth, gradually changing, in other words, nonlinear warping of that parking lot surface. And there were some techniques that you use to make the surface change and not just the contours. And the tendency is for a lot of people, especially people that don't really understand what these contours are doing, is to just turn the smoothing on and ignore the surface underneath. But in our modern day and age, because we're using the surface to load onto a machine to go out and build that surface, we need the surface to be correct, not just to have pretty contours. So you need to, and you'll get that experience after you've worked with these a while, that you'll know why the contours are sharp and angular and what you need to do to supplement the data to fix the contours. So in other words, don't cosmetically fix it. Don't put something on there that's going to artificially just put a Band-Aid on it. Go back and actually change the data that was used to build the surface and recreate it until you're happy with it. All right, that's the whole process behind this. And that's another reason why, by the way, when I'm drawing contour, or when I'm modeling a surface, when I do triangulate and contour, I almost never draw the contours at that point. So I would come in here and I would simply uncheck this. All I would want to do is to compute the surface, and then I'm going to look at it over in my 3D viewer and do all kinds of evaluations on it before I'm satisfied with it. Once I am, then I would go and run another command that draws the contours from that surface file that I previously modeled. I don't have to go back and remodel it. So this triangulate and contour, hence the name of the command, is triangulating, it's computing, and it's also contouring. So it's combining the computation with the drawing of the contours, which I can do separately without having to do it here as part of this step. But in any case, let's take a peek at what this is going to give us. Now, we've turned the contours to draw the contours on. We just take some defaults there. Look at the labels tab. And again, I'm just going to leave the defaults set for these layers and up there. And you've got the, this text size and the minimum length and all that. But look at these check boxes down below here. These are some things that you might want to do or might not want to do. One of which you would say, oh, I want to break that contour at wherever the label goes. Well, that's true, you could, and that actually breaks the polyline and takes a segment out of it and then lets the label live in the gap. Okay. Well, that's fine, but if you need to move the label around, then you got to go back and draw a little piece back into the contour, then go to the new location and chop a hole in it and put it back. So I don't like to do that very much because there's over here on the right-hand side, there's this option to hide the drawing under the labels. And that works by creating a wipeout to go under the label, but sits on top of the contour, therefore hiding it, whatever's underneath it. It also hides other things. So, if you got a fence line crossing underneath it, it'll also hide that as well, but just for the space of the text. So it's a very nice and handy little way to do it. Then you can also then label only the index contours or not. Usually that's the way we do it. And you usually align the text with the contour. And I'm going to draw them on the real z-axis. In other words, put the text up at the contour elevation, not down at 0. Okay. And then there's this curious little one over here that says align facing uphill. And that's an old technique that's not used a whole lot anymore. But it's done in very flat countries. So sometimes you might be in, down around the coast, and your entire map might only have a single contour going across it. Well, if that's the case, you can't really tell you know, which way is uphill, you know, up and to the left or down and to the right. You don't really know. But if you turn that switch on and you put a note somewhere on the map that says, hey, all the labels are lined up facing uphill, that means you put yourself to where you're reading the label correctly and you're looking in the uphill direction. All right, so it's there if you want to use it. And then the label intervals. You can either label by an interval, meaning you've got, one label per contour, two per contour, regardless of how long the contour is, that's what you're going to get. Or you can do a distance interval. So I'm going to make this say 300 feet um, instead of the 150 that was left over from before. Or you can use this scalar button. Then the scalar button is how far along the contour, if you were to measure that at the plotted scale that you want, say 4 inches between labels. So walk around the contour line for 4 inches if it were plotted, and put them, drop the label down, that sort of stuff. Okay. All right. Now let's go to the triangulate tab, and we'll talk about how this works. The very first checkbox is whether or not you want to write the triangulation file. I'm going to recommend that we do, because you want to save this file, because once you have the file, if you remember yesterday at the end of the day, I was loading up those surfaces in the 3D viewer and you could see them, and I showed you to make them semi-transparent, or you can apply a texture to it and all that. That was a file that was created and saved and stored somewhere else at a previous time. So it doesn't live in this drawing. It lives outside of this drawing, which is handy because we can always use that file to recreate contours from. And we're not, even if we crash this drawing beyond recovery, we can recreate much of everything that becomes a part of it. You can do the same thing for center lines, for profiles, for coordinates. So we're going to write the triangulation file, and I'm going to choose the little button to the right of it that says select. And Zoom's got me again. All right, you have to wait on it to finally come back and pop up my selector button. But when you choose select, make sure you're in your project data folder that you're working in, and just give it a name. Come on. There we go. Good. Heavenly days. All right. So here I'm in my, wow. Huh, totally wrong class. Let's see. Well, maybe it was. I was looking for an '09 date, and this is October already. All right. So I'm going to call this file. I'm going to be in that folder, EG, which stands, in my case, for existing ground. I'll say dash from CTRS. So existing ground from contours, because it's all the data that we've got out there. And I'll say save. All right. So that's the file I'm going to create. It shows me the name. And then I've got some options to draw some things from the file, and it draws them into the drawing. Now, you can do that if you want, but my recommendation is to not hog up your drawing with all those drawn objects, because it's every little triangle edge is going to be created and stored in your drawing. So you can always see those in the viewer, or you can always go back later and draw those if you need them for any particular reason. Okay, so we will do that from time to time if we need, but we're going to look at this and, well, actually, you know what? Let's do that. Let's draw the triangulation lines. I'm going to be able to, I want to show you a couple of things that result from that. Okay. Now, this use inclusion and exclusion area, for now, uncheck it. And shrink wrap perimeter reduction, for now, set that to none. We'll come back and talk about those in a minute. And erase previous contour entities, leave as off. And let's ignore zero elevation, so we have that checked on. And let's uncheck everything else. And let's say OK. Now, the cursor changes into a selector cursor, and it's asking us on the command line to select entities, but read the line above it so you know what it is you're selecting. That's important with this command, because when you change different options, it's going to ask you for other things, and we get in the habit of just swooping in real quickly and drawing a window. But in this particular instance, it's asking us to select all the points and break lines we want to use to triangulate with. And this is where we can go out to the left, click a window, and grab everything within it, or we could type the word ALL and hit enter. So anyway, I clicked that, I've selected everything, and it still is asking me to select entities because I'm building a selection set. I need to tell it that I'm done by pressing enter. So I hit enter, off it goes, and you see some words go by on the screen, and then it starts to draw the contours. Well, look, here's a couple things. I see the contours line up over top of the other contours. That's good. So I'm going to freeze my contours just for the moment, and we'll talk about these triangles. So I'm going to say freeze layer. I'm going to go up to my view menu and choose freeze layer by pick. And I'm going to scroll in there and pick one of those red contour lines and one of the white contour lines. All right, so now all I've got are the triangles and the original data. So what I want to do is I want to see the original data over top of the triangles. Notice that my triangles are obscuring the things underneath it, even though they're probably at the same elevation. And that's because of draw order. So what I'm going to do is I'm going to select all of my triangles, and I'm going to change their draw order to the background so that I can see the other things in front of them. Okay. So how do we do that? I mean, if I try to just draw a window around everything and select it all, I'm going to get all those other things that are underneath that I want to leave out on top. So how do I get just the triangles? And that's called a selection filter. So if you do this, if you go out in space here with the mouse, press escape to make sure nothing's selected, and then right click the mouse and let's choose quick select. That's one way of doing it. You can also select one of the triangles and right click the mouse and choose select similar, but sometimes it gets more than you want. So let's do a quick select. We're going to apply this to the entire drawing. The entity type that we want, those happen to be lines, but we'll just say multiple is fine. So anything, but I'm going to choose this layer and I'm going to say my layer equals, and that went on a layer called TRI lines right there. So my layer equals tri lines. And I want to include that in a new selection set. Notice you can use this to help you build a selection set. All right, but we'll go ahead and choose it like that and say okay. And now it is selected. Now I do get a new notification that I've got more things selected than it can show the grips for. That's no problem. I found 27,719 triangles. So while they are selected, I'm going to right click the mouse. And when this menu comes up, I'm going to choose draw order and go to the right, and I'm going to choose back. So I'm going to put all of them in the back. And now when I come back out, I can see those original things underneath it. The reason I did that was to talk about some of these problems that could happen. Because if you remember, turn on my line weights again. And I'm going to change those contour layers, which was V, topo major, and minor. Major and minor. Instead of default, I'm going to make them big so you can see them. I'm doing that just for illustration. You don't have to do that on yours. But so here's what's happening. Those triangles are what is defining the surface. And it did that by reading all of the little vertex points along these contour lines. So if I select a contour line, you see how all of those vertices have points as part, the triangles all come together to form at those points. So right now I can look at this one right here and I can tell there's a triangle right in here, or even this triangle in here. And I can tell that those two triangles are not correct because this triangle that's in here, this little skinny one, or this little small one, is the same elevation as that contour line because it used that elevation point, that elevation point, and that elevation point. They're all the same. But really, it should be a little bit higher than that. If I were right in here, I'm off that contour line, so it's got a different elevation, but the computer thinks it's the same. The same thing happens right in here, that triangle, and those are called flat triangles. They're not generally valid. Here's another one right in here, this triangle, or this, well, it's a line, but that line, see, that's a triangle that got formed right there. Same thing in here is another triangle that got formed in here that's not correct because the triangles were to say this has an elevation of 1,307. I see over here in my start and stop Z elevation. but really it should be 1307 at this point, but 1306.85 at this point, and then back to 1307. So you see what I was talking about, how if you don't use those break lines, you're going to run into some real issues. And here is a problem that we were talking about earlier. In fact, here's one where even two of these triangles are formed and they're not correct, because it's saying that this elevation, whatever that contour line elevation is the same all along this edge, but it's not, because it's really, you know, somewhat lower than that. So that should come down and go down into a valley and up back out. So I should have had that break line drawn in between there. Okay. So that's another one of the problems. Look at all these triangles over here. Now, these are triangles, but they're awfully skinny triangles.
And would all those incorrect triangles be fixed with that break line drawn up, that ridge or the valley?
Yes, if we draw that break line in there and include it, then it will be fixed. And we're going to do that next. We're also going to learn how to get rid of these triangles over here on the side. And you can edit a surface file after you make it by deleting triangles. But then if you have to go back and rebuild it, you'd have to go back and delete the triangles again. So the best thing to do is to figure out some means of getting rid of triangles that you don't need beforehand. So like all of these, all of those triangles and all of these triangles, need to go away. Is, that's what we're looking for, is something like that, and not what we just wound up with. Okay. So let's take a look at those means of doing those. And so again, if I wanted to erase all of these triangle lines and get them out of my drawing, tell me one way I can do that. What did we just do when I,
Can you freeze that layer?
yeah, you could isolate that, or you could freeze the layer. All it does is take it out of visibility, but it leaves it in the drawing. If I want to actually get rid of them, to delete them, how could I delete them from that layer? All right. Think about what we just did. I selected all the triangles and I put them in the back. I moved them in my draw order. I did that with a quick select, remember? I could
You
also,
can quick select delete.
well, yeah, you quick select, and what it does, um, if I do that quick select and use the layer equals that try lines, see, it says include a new selection set. When I hit OK, it's going to select. See, did you see it change? They're dashed now. So they're all selected. So now all I have to do is hit the delete key and it would get rid of them. That's one way, right? What's another way? You could isolate that layer, right? And then draw a window around everything and hit delete. That's another way. You can also, and this is more similar to the quick select, if you're pretty certain that there's not other things on the layer that you need, or that there's only one particular line or one particular data type, like lines or polylines, if you select one of them and then go out to the side and right click and choose select similar, well, it'll find all of those and they're all together, and then you can just press delete. All right, so that's nice. But here's an even nicer one. Let's go to the edit menu and choose erase. And it's also on our also on our layers toolbar. And it's called erase by layer. It looks like a pencil eraser sitting over top of a stack of party pancakes, different colored layers. And so when we erase by layer, up pops this, and we can either type the name of that, or we could select it from from a list of layers if we know what it is, or we can select it from the screen, and you can select it by either just picking a single one, or even you could drag a window around it and it would get everything that it crosses. But right now there's triangle lines, it's done. And then you can say if you didn't want to get rid of the lines, but you only wanted to get rid of the text and any solids and any text, you could filter what you're getting rid of. But we're going to take all and we'll say, okay. So that's going to find that layer and get rid of everything on that layer. Now, the reason I say that that's pretty nifty way of doing things is for this particular reason. Let's say I had more than just that one layer, that I had selected a bunch of things that maybe I'm doing a trial and error design on something, and I've got 5 or 6 different layers that it generates and puts stuff on it. And I look at it and I see, oh, I got to fix something, so I got to get rid of that other stuff. All I have to do is go back and run that command again, and that layer name or the list of all the layer names stays in the field. I don't even have to go back and reselect it. I just pop that up, hit OK, and it's done. All right, so that, in the case of the triangles, that's no big deal, but it's just a nifty tool to have at our disposal. Now I'm going to go back and turn those contours off, or change their weight back. Now, here's something else to let you know about that might be helpful when you got dozens and dozens and dozens of layer names. You don't want to deal with them. Up here in this top window is a little filter. When you run this command, you can use that to filter what layers show up. So let's say I know that that's on a layer that starts with anything. So that's, I've got that asterisk. That's an asterisk that you're looking at. So asterisk TOPO, and then another asterisk. So starts with anything, includes the words topo, and ends with anything. Well, I see my 2 contour layers right there. Sometimes your layers are called, CONT or CN or CTR for contour. So just use that to help narrow this down if you want. And I'm going to come up here now and choose this line weight, and we'll set it back to default. And now that's going to make them go away. Now, when I run that command again to look at my layers again, that filter goes away. If you're running the AutoCAD version of it, that filter stays in place until you reset it back to just plain asterisk. Okay. Now, let's go. I remember I turned off, or I froze the 2 contour lines that we, or the layers of the contour lines that we created. So I'm going to go back to my layers, and I'm going to find the 2 that we froze. And they were on, if I recall, there was CTR, I think. Yeah, contour intermediate, contour index. So I'm going to take those, and I'm going to hit this little snowflake, turn it back into a sunball, so ours get turned back on. Now, comparing the contours, you can see how, your contours are pretty close to where their contours are, but you can see those spots where it jumped across there and made those flat areas, like look at this right in here. So between this contour line and this contour line, but really it should be this to this. See, but they got lopped off because they're flat triangles in there. See? So let's do this. We're going to put a um, break line along that segment between those points. Okay, so go over here on the left-hand side where that road is. Oops, let me get this out of here. And let's zoom in. Now let's go back over here to our status bar in the bottom right where it says entity snap tracking on and off, and double click it, or rather right click it and choose settings, and make sure you've got endpoint turned on. I don't care about the others. Just don't have nearest, but have endpoint on, and say okay. And then make sure it's on by double clicking it so the icon turns on. Yeah. Now, let's go back to the layers.
What were the things we needed to have checked one more time? So,
Just when I go over here, right click settings, I want endpoint to be turned on. And I don't care about these others. I just want you to have endpoint and not have nearest. Okay. Just so that when we draw this, we're going to snap to those corners. That's what I want to have happen. Okay, everybody good? So now what I want you to do is to zoom in over here on the left-hand edge. Let's go in here somewhere. Say you might notice this little rounded set of contours in there. So come down below that a little bit, like right in here. And I'm just going to go between these two red contours so you can see a portion of it. Okay. I'm going to go back to now my draw menu, and I'm going to draw a 3D polyline. Okay, and I'm going to make sure that I've unchecked the prompt for elevation and slope, because I want it to read the elevation and not make me have to confirm it. And down here at the bottom, if it says use current drawing properties, uncheck that, and for the layer name, I'm going to use 3D-BRKLN. So 3D break line. I'm going to say okay. All right. And now I'm going to come to where these two red contour lines are showing. I'm going to zoom up here above, and I'm going to just hover over that. And I want the green one, not the red one, but I'm going to hover here, and I'm going to click that point. You see, and it read the elevation. If you look at the line above the command line, it says Z of 1305. So I'm going to use that, and I'm going to go down here and grab the next green peak and do that one, the next green peak and do that one, the next green peak and do that one, all the way down. Now you have to be careful that you don't cross over one of these as you're working, but that should be enough, just something like that. Now I'm going to change my 3D break line to be this magenta color so you can always distinguish it. So there's that break line right there. And we're going to run this command again, and we're going to look at the difference right in that area. Okay, so let's go back to surface, triangulate and contour. And this time on the triangulate tab, where it says write triangulation file, that's fine. I want to do that, but I'm going to hit the select button because I'm going to make a different file this time. Of course, now I got to wait. Just bear with me. This is a Zune thing. Come on. There we go, finally. Good heavens. All right, so instead of EG from contours, I'm going to say EG from contours and then dash BK or BRKLN, the break line. I want to give it a different name. Now I'm also going to go to the contour tab for right now. Oh no, let's just leave it alone. Wait a minute, no. I'm going to go to the contour tab and uncheck draw contours because the red and the white contours that it drew before are still there, and it's going to, oh shoot, you know what? Cancel this for a minute. We have to erase these, otherwise they're going to be included in the data. So let's erase by layer. So I'm going to cancel my contouring. I'm going to say edit, erase, erase by layer. And I'm going to select from the screen. Now notice that tri lines was still there. So I'm going to take this and this, and also it's text in the white, but it's the same layer. Okay. So I'm now going to select all of those, and notice the tri lines is still in here. So that's the thing I like about this command, is it just keeps building a list of layers unless I hit clear. So I'm going to say, okay, all right, now.
I don't have all those layers on there. Mine is just tri lines. How do I go back and add those other layers?
Select from screen and then pick one example of one of your red contours and one of your white contours. Did you get it?
No, it's jumping all over on me. Can you walk me through it one more time?
Yeah, you're going to go to erase by layer, okay? And, if it has whatever was in there last time. Now, if there's nothing on that layer anymore, you could just hit clear and get rid of it. But regardless, you could say select layers from screen. So you click that and your prompt changes into a select entities. Read the line above, select entities on layers to be deleted. So you would select just one of one, say the one index contour and one intermediate contour. And when you're through selecting, hit enter, and then that's going to come back and it will have filled out those layer names in that list. Okay, and I'm going to say cancel because I'm going to keep those. Did that work?
Yeah, I think I got it.
Okay, great. Now, let's go back now to surface and triangulate and contour. And this time where it says right triangulation file, hit the select button and change to a different file name. Okay. And I'm going to uncheck this draw triangulation lines. I don't want to draw those lines anymore. But the contours, I'll go ahead and draw so you're going to see the difference in that area where our break line is. And then we're just going to say, okay. And it says select entities. The line above says select the points and break lines to triangulate. So we'll just grab everything like that. Off it goes. It's going to run through here and come up with our surface, and it's going to draw the surface. Now let's zoom in to where we drew that break line, and wow, look at our contours. They laid right over top of the other ones, you see. Look on the other side of the street. See the difference? And then look where we did not have the line. You see the difference in there? Like it did last time? Now let's take a look at the surface that we just built. In our 3D viewer, maybe see it a little bit more readily. If we go to the view menu, 3D view, and let's choose our surface file viewer. I'm just going to wait for the file. And the surface file, now notice here, see, it's telling me up at the top what to pick as a surface file, and it gives me the file types, tin, fault, or grid. And the one I want is this one that we just made, that EG from contours and break line. I'll say open, and off it goes. Now I'm going to do a couple of things here. I'm going to go to my settings tab, and I'm going to turn off the contours. I'm going to go to the view control tab, and I'm going to grab this little yellow square and drag that around until I'm sort of in the upper left. And then I'm going to slide these light control contrast things. This is the light source. You can think about that as the sun in the sky. Right dead center is high noon, directly overhead. Right down on the edges, that's sunset. So I want to be, you know, I want to cast some shadows. So that's the direction, and you just kind of move that around until you get it, till you're happy with it. Now, here's how to visualize, how to zoom in and spin this thing around. If you make sure down on the right-hand side that the lock on for that middle row for the y-axis, make sure that's on and the other two are off, because that's going to help us. Also, if you're not seeing the surface, if you're seeing that, this button that is a toggle that colors in the triangles, okay? Now, you might also have yours set to color by elevation. That's perfectly fine. That tells you the high spots, the medium spots, the low spots. I don't particularly care for it all the time, but it's there. Now, here's how to navigate your way around using just a few of these buttons over here and some techniques. If you choose the arrow, the big black pointy arrow, that's just a pointer. But notice down here on the status bar that it's telling you where you're pointing, what that average elevation is. You've also got these little clipping sliders where you can, you know, adjust that along all the different, you know, near, far, top to bottom, that sort of stuff. But so this one for the pointer is going to point to different things. It also lets us, if we're viewing a surface file, which we are, it lets us choose a technique to edit the triangles. I'm not a big fan of triangle editing. I'm a better fan of fixing the problem. Like right in here, I can see there's a problem with these triangles. There's probably needs to be a couple of additional break lines in there. And so I would go back out to the data, draw those break lines in and recompute it. I wouldn't sit here and try to edit the triangles to make that happen. But in any case, that's what this little pointer is for. We don't use it a whole lot. The big one that we use most of the time, the navigation ones. Now here's one that's a little hand, that's pan view, so it just slides it around. But you can do that with the wheel mouse just like you do in regular CAD. Same thing with these zoom little magnifying glasses. That'll do that kind of stuff as well. You can use the wheel and the mouse. The other two, lower, the far right bottom and the next to right bottom, you can say return a view to plan view. So let's say if I've zoomed in and, you know, if I'm all, you know, spun around, but if I choose return to plan view, it keeps me at the same height in the sky, but just recenters me back to north up and flat straight down. If I choose this button, it's similar to that, but it does a zoom extents. So it goes out and shows you everything and puts you in plan view. Now, here's the one. Here's the granddaddy, the one that we use most of the time. It's this second icon from the left on the top row. It's called rotation mode. And it looks like a little cube and an arrow circled around the bottom of it. Now, hover the mouse over the drawing. You see as I come in from the right, the cursor looks like a Z with a little arced double-headed arrow on it. And then as I get over the data, at some point it's going to switch. Now, there's no real definition because you're looking at this in a perspective viewpoint, by the way. So, it vanishes to a vanishing point behind it. But basically, when you're over the data, over the bulk of the data, it changes to an XY cursor. And when you're at the edges, it's a Z cursor. Okay, so here's how to work this. And this is how you can always figure out how to position this to look at something that you want. Now we're going to want to be looking at this road edge over on this edge. We'll do that one first. But I also want to come in up here to this edge and look at some things going on in there that I know are also wrong. But here's how you do it. You're going to zoom out enough to where you can see your data. And I want you to think of this as if you've walked up in your driveway and you're looking at your garage door, all right? That your garage door closed and you need to open up the garage. So position the cursor down toward the bottom before it turns into a Z. Just make sure it's got the XY. Click and hold the left button on the mouse and hold it. And now while it's held, just push it straight up. And notice if you go left and right, it doesn't roll. It only rolls up and down. And that's because we have that Y-axis lock on. So our objective is to roll this thing up to where it's pretty oblique. It's almost up flat open. And if I need to go back and grab another chunk, let the mouse button up, go back down to the bottom, grab another chunk and position it to where it's about like that. Okay. And next, let the mouse button up, push it down to the bottom now. And you notice if you move the mouse now back and forth, it's just going to spin it around at that same obliqueness. So I'm going to spin this around to where I'm looking toward where I wanted to be zoomed in at, right? And I can go back and sort of fine tune it. But I open it up, open up my garage door, lay it back almost flat, spin it around, and then point to it with the mouse. Lift the mouse up and point to it and just use the wheel to roll in. And now here's what I was talking about. If I zoom in like this, right in there. Now I'm going to drag this slider around so you can see the shadows change. But here's the result of that, what we did. You see the you see those little stair-steppy looking areas? That's where those contours were squared off. And where we put the brake line in was right in here. And you see how nice and crisp it goes down and follows that all the way down until we get back into, some of those other problem areas. But that's what that brake line did, was to redefine that ditch as being continuously changing instead of going up and down this the little stair steps that it creates when all you're using is the contour data. Okay. So see the difference there? Now, and you look at it over here on the other side of the street, you see all those other kind of invalid triangles. See how they form there as well. I guarantee you that's not what it's like, and we'll compute what it is like and see the difference. Now I'm going to zoom back out. I'm going to spin this back around, and I told you I wanted to go up there and look at that area right in there. So I'm going to sort of position that up, spin it around, get it, and then I'm going to roll in. I'm going to look at it and I say, wow, what the heck is going on with that right there? It looks like a big loading ramp, loading wheelbarrow ramp or something, doesn't it? And I know from my site that that's a retaining wall right there, but I don't have any data other than the drawn contours. And so there was an end of a contour somewhere. They jumped out and found another contour somewhere else. Now, if I go into my settings tab at the top right, I'm going to check on to display the contours, which is the last checkbox at the top. Then that would be what those contours would look like. But you notice those contours never existed in the drawing. Those weren't the ones we used to make the site from. These are the ones that it's using, that it's computing, and that would be how it would draw them. Okay, some of them are okay. They look all right, but the ones that are a problem, now I'm going to come back here and reposition like this and zoom back down here. Let me get a little closer, a little less vertical here. And now you can see right in here, you can see where those red and white contours came across and were squared off. And let's see, let's turn on the triangle edges too. Yeah, that's a little too much. So, and yet you can see where I started to draw in the break line. You can see how it sharpened up those contours. And then when I finished down here, I went to there, but then I didn't go on. You see how that chopped off square again? Now here it didn't chop off square, and that was just a happy accident. Over here it did. All right, so there's all kinds of reasons why we need those break lines. All right, but that's the key technique in this. And if you get all wrapped around and can't figure out how to straighten out your view, just go back to your view control tab, hit that view or hit the icon on the lower right, and then you can reset what you're doing. Raise up your garage door, spin it around, and then wheel yourself into it. And when you're done, just hit the exit button, the little go out the door button, or the big red X. Okay? Everybody get a good sense of how that works?
Yeah, I really like that tool.
Yeah, oh man, you're gonna learn to love it. I will do that when I'm modeling things. I'll build a surface probably 10 or 15 times before I'm done. And I'll build it, I'll look at it. Oh man, I see something I gotta fix. I'll go back, fix it, build it again, look at it until I'm satisfied with it. And then at that point is when I use this other command. Like I told you, I don't generally draw the contours as part of the process. That's when I would go to surface and I would say contour from tin file. And that's going to make me go out and pick the file and it will create the contours. It basically does the same thing those two tabs do in that combined command. But I just do that to keep from drawing these goofy contours. Okay. But yeah, you can see right in here, for instance, another spot where the white contour was ours, the green was theirs. So, but you know, it missed it. It didn't know, it's whatever it was doing because the only data it's using is the data along the data that exists in those contour lines. Okay, so I think you get the idea how this can be really bad. But so many people do this all the time and they don't get any errors and they go, oh, it must be correct. So just be aware. Okay, so always use contours as the absolute last resort. Now, I'll show you another quick technique, and then we'll take our break. I'm going to select that break line, and I'm going to delete it. So I'm going to go back to the same thing, and I'm going to delete or erase by layer again. So I'm just going to choose the two contour layers. And Now, there's another little technique that you can use that can help do some things, okay? You could, for instance, up here where you saw that big loading ramp, you could, like, you don't necessarily know which of these and how they got cut off, but you could draw a line from like one of these across to the other, and that would keep that long ramp from looking down here. You'd still get some jump outs down in here, but you could fix that um, somewhat. But now, here's the other technique I was telling you about, as I'm getting ready to tell you about it. Let's go back to surface, triangulate, and contour. And I'm gonna keep forgetting. I'll try over lunch to reset everything to see if I can get it. In fact, at our lunch break, I'm going to actually, well, never mind. I was going to say I'll kill the meeting and then restart everything, but I'll just restart Windows. I can do that and still keep the meeting going. See, I don't know if this is something that happens when you're running Zoom and you're just going out to try to find a file, like just using Windows to find a file, or if it's Carlson specific. I don't think it's Carlson specific because as soon as I'm out of Zoom, this doesn't happen. But in any case, all right, so I'm going to call this one EG from contours. And I'm going to say dash no flats. I'm going to say save. And now before I hit the OK button and go ahead, remember I took that one contour or that one break line that we drew, I took it out. And I'm going to stay on this triangulate tab, and down here at the bottom is this little button, or toward the bottom, a little button that says minimize flat triangles. So in other words, when it sees those flat triangles, it's going to say, I don't really want to use it if you're going to be a flat triangle. Now notice it's with a group of check boxes that's inside this little frame that says adjustments for source data of contours. Because they recognize that sometimes that's all we have. And these are ways that are going to help you use that data without having to go through and draw a lot of stuff. Okay, so I'm going to say minimize flat triangles. This interpolate ridges and valleys doesn't really do that same thing that or same as flow paths. It doesn't do that. What that does is it tries to push them longer, to interpolate them, to push them down the slope. It really should say extrapolate instead of interpolate, but still. Same thing, summits and pits. If you have a couple of concentric contours, like if you see over here on the right hand side, I can't zoom in to show you right now, but excuse me, if there's some concentric contours around the edges of that pond, if I were to say interpolate summits and pits, it would see those concentric closed contour lines, and then it would try to push it all the way up to it ran to a point. So, it's as if somebody contoured it and then didn't go up finish it. Otherwise, it's going to flatten it out. So it gets rid of the flat part across. It just keeps pushing it up or pushing it down if it's a pit. All right. So let's see what effect this minimize flat triangles has on it. And we'll say, okay. And it asks us to grab our data. We want to grab the data. We'll enter. I forgot. Oh, well, we can go ahead and draw the contours again. But now zoom in over there on the road edge and look. Indeedy. See how much that cleaned up? Now we still have some problems like right in here, but look at that. It's as if I had drawn those down that edge. Now I still got, this problem over here was still happening. I've got, over here, it used to be that this was all one big flat area. So there's still a couple of areas that are problematic, but nothing like before. And in fact, if I go back to view, 3D view, and I look at my surface file, excuse me while I slurp my hot tea. And this is the one that says no flats. And I'm going to go over here just for yucks. And let's change our color. And I'm going to check the contours. Turn the intensity down a little bit. So now, pushing up my garage door, spin it around. Now look at that nice crisp edge down that road. Still have some problems over here because that's a sidewalk, but you can see how it really took care of a lot of that. There's still that little loading ramp partially still a problem, but not, maybe it's even worse. I don't know. All right, so you're learning a couple of techniques that are going to help you minimize those things. Now we've still got, these triangles that we need to get rid of and on the edges and all that kind of stuff. And we'll do that when we come back at the break. So we'll go ahead and exit that. I'm going to run my erase by layer command again. And this time I don't have to pick it because it's already in my list. I just hit the OK button and boom, they're done. Okay. So I'm going to restore the layers for me. No need to save that. I've got my surface files out there, all good to go. I don't think I do anything else, save it just for yucks. I'm going to restart part of my system here over the break. But let's come back at 11:30, and then we'll take lunch at 12:30. It'll give us an hour to wrap up some stuff before lunch, and then we should be able to come back and we'll try hitting that exercise of putting everything together and seeing what we can do with it. Okay. Any questions to date? Everybody good? All right. I'm going to pause the recording and hope I remember. How about that? All right.
I'm back as well.
Good. All right. There's John,
Also back.
Jim, Cyrus, and Jacob.
I'm here.
All
Present.
right. Sounds good. All right. So I restarted Windows. Let's see if I can get rid of that file picker lag issue. Might have to switch to using Teams, although I hate Microsoft even worse. So here we go. All right, I'm gonna open this back up. Now, So there's the problem with using contours as our source data. But so let's do it the way that the photogrammetry company did it. And let's go to, we use the data, but we have to freeze off the contours, their drawn contours, because otherwise, if we select all this data, those contour lines get red, as do all those little white lines, and you're going to have all kinds of crossings and, misalignments because they've done some edits on things, and it's just going to cause a problem. Now, right over here is where you can see that retaining wall, where it comes off here flat and then drops down the face of that wall. And so they did that by compiling that in the viewer. Now, so what I want to do is let's go to the view menu and let's say thaw/on all layers to make sure everything's turned on. And then let's go back to the view menu again and choose freeze layer by pick. And I'm going to zoom in and I'm going to pick one of the index lines, one of the index labels, one of the intermediate lines. Now they're all going away. And now I need to make sure I get these two obscured areas. And now I'm finished. I'll hit enter. So now I'm left with that. That's going to be what I want to use. Okay. So now let's go back to triangulate and contour one more time. And this time I'm going to select. And apparently it didn't fix the problem. All right. It wasn't quite as bad. So this time I'm going to say EG from break lines and spots. Okay. I'm going to come down below here and I'm going to uncheck that minimize flat triangles because I don't have contours there. It's not going to be a problem. Notice I've also got this ignore zero elevations. So I can leave all of that stuff that's underneath there drawn on. I can leave it turned on the screen, and when I select it, it's going to ignore it. That's what that switch is for. All right, so I'm going to say okay. And again, wants me to select entities, reading the line above, select the points and triangles to triangulate, or points and break lines to triangulate. I grab it all, I hit enter. Now you're going to see something pop up here in a minute. There's a little error log. It shows me where I've got a couple of problems. I didn't get this in the contours because these things did not happen with the contours as data. But there are three types of errors that can happen. You can have break lines that cross each other, and you can have vertical edges. We can't use a vertical edge because it can't compute the triangle to have an infinite slope. All triangles in these surfaces, in these tins, have to have some measurable slope, even if it's almost vertical, so that it has a computable slope. Otherwise, it's going to cause some divide by zero errors. And the other type of error you can have is called a T intersection, which is just like a crossing break line, except one of them doesn't cross on over to the other side, but it does meet at that T intersection. And it's okay to have the data do those things as long as where they meet or where they cross, they have exactly the same elevation. And these do not. So that's where the problem is. I see I've got 2 vertical edges, I've got 3 crossing break lines. Now, how you find out where those are, first of all, let's go down here to this settings button and and look above the buttons. It says filtered out 16 errors that were below the tolerance. Okay, so if we go to my settings, I see that I can have 1/100th of a foot. If it's lower than that difference in elevation, don't report it. Okay, but you could tell it where to go, what layer to put the symbol on. You could draw an X and all of that. Now, each of these categories are things you can open up and you can find where they go. So if you don't have them opened, you see the number of errors you have there in parentheses or in brackets afterwards. If you do have it open and you click on one, it shows you in parentheses the difference in elevation. And there's a difference in that elevation. And down at the bottom, it shows you the XY coordinate of it, and it then repeats the Z difference. Same thing for that one. Vertical edges, same thing, okay? So the way you can fix this is, notice as you click on each of these, there's a little ghosted arrow that moves around and shows you where those edges are. So if I get on one of those, and if I go to zoom to, it puts it in the center of the screen, and then I can zoom in repeatedly until I see where it is. So, aha, so I've got a vertical edge there. Now I can't see that as a vertical edge, but if I were to slightly roll that up, you can tell where it is because it's doing the contours again. Let me erase the contours. Now I'll be able to tell it. So right in there, they're saying I've got something that is vertically over top of something else. And it's just right in there. Now these down here are down at 0, so I'm not so worried about that elevation. But it was somewhere in here, and it was just 100th of a foot. There's a little drop off, probably right there. So if I see that, that's an elevation of 1300.81, and this is an elevation of 1300.80. So if I really were going to be a stickler about this, I would fix it. I'm just going to zoom in here, select that, take the grip and move that grip up into the grip of the other one. So I've just raised the elevation of that one point up to meet that other elevation. All right, so that fixed that one. I could go to here, zoom into there, and I've got a similar situation here. Now, I'm not going to take the time to go through these, but I just wanted to show you how you go about it. Here's another case. If I zoom over to here and I zoom in, now this happens to be an area around the head wall of a drainage pipe of a culvert. And they've got these lines crisscrossing, and this is, and when I say they have, I mean the photogrammetrists got in a hurry and they did do a little, QA QC on this stuff. They just missed that. So I would go in there and maybe make some edits or send it back and ask them to fix it, that kind of stuff. And right there's where they cross. Right there's they're crossing each other. So, and I've got some other places where they cross. So this is the edge of this road that's coming down here, and it's crossing the edge of this road that's coming over here, and you can see. And so really the easiest way to fix that is to just break this line off. And then that'll take care of that. Okay. And I could fix all those others. It's not worth going through right now because and if you choose to exit and leave it alone, then the file is already built. It showed you where it had some errors, but it went ahead and it chose which one of those elevations to use. And it went ahead and built it accordingly. It didn't tell me which one it used. And I don't really care for now. So we've got a good surface. So let's compare a couple of differences. So let's go back to our view menu and let's do a 3D view, 3D surface file viewer. And pardon me while that comes up. Yeah, I think over lunch, I'll shut everything down and restart the meeting because this is unacceptable. We'll see if that'll clear it. All right. So the surface file I want to look at is, first of all, the very first one we did was the EG from contours. So I'm going to load that one in. And that's going to be that clunky-ish one. And now I'm going to go to the model tab at the top right and click that. And I'm going to choose the little icon that looks like a little stockpile. That's the surface icon. That means to add a surface file. So if I get that one, I'm going to get the other one on. So I'll have two surface files loaded in here at the same time, which is perfectly legal and fine to do. You can have many. There may be some programmatic limit, I don't know, but it'll do these. Now I want to get the last one we just did, the EG from break lines and spots. And I'll open that up and it's going to have its own separate color. Now I'm going to open these down below here under the surfaces. I'm going to set my surface properties. And this is the one, let's put that one to be, it's going to be a good one. We'll make that one 83. And this one, I'll right click and choose edit surface properties. That is, oh, actually, this is the good one, sorry. And this one was the bad one. So I'll make it sort of a reddish color. Okay, now, all I have to do here is if I check this box that says double click to toggle visibility. So I'm going to toggle, I'm going to select that second one I loaded. I'm going to double click it. So I'm just looking at the first one. I'm going to go back to my view tab now so that I can grab my view icon and spin it up. And there's the one. Oh, man. Oh, there we go. I needed to make them not opaque. I couldn't figure out why the lighting level was so bad. All right, so there you can see all of those stair-steppy things that we've been dealing with. All right, now let's go back to the model tab and I'm going to double click that first one, turn it off, and double click the second one, turn it on, and look at the difference. Not only did it fix all of those over there because we were using their break lines, but look here on the right-hand edge, it fixed that as, and you can also tell there's a little bit of it's actually a little flat walking area. It's a bit of a sidewalk. It's not perfectly sidewalk, but zoom in, for instance, now, and You can see those curbs are all nicely well-defined. The retaining wall up here in the back across the street is all well-defined. And remember that big ski jump that we had right here along this loading dock area? See how that took care of that? Okay. Our little pond over here and our perched pond above the other little pond. So a lot of things are a lot different. Now, even though this is the surface, not this one, that when I ran the data, it gave me the errors, but it's a much better surface. Okay, you see how that is? And I'm making that determination with my eyeballs. I'm looking at this and I'm saying, wow, that's much more representative of what's out there on the ground. So don't be afraid to make those kind of assessments. And even though you got an error on the one and you didn't on the other, does not mean this one's wrong and the other one's right. This one's a much more right than the other one is. Okay, now. Let's do a couple of other things. I'm gonna go ahead and exit my viewer. And let's talk about those boundaries. So I'm going to go back to my surface menu. And I'm going to come down here below where it, at the bottom part of it, and it says, well, it's not here on this one. It's middle. In civil, it's at the bottom. All right, so on the surface menu about midway, it says draw surface. I'm going to draw the triangular mesh. I'm going to draw the triangles again. So it's going to, whenever it decides to let me pick a file, come. All right, I want to get the, here's our good one from Break Lines and Spots. And I'm going to use lines. I'll go ahead and put this on our tri-lines layer, same deal, say okay. All right, so here's all our triangles.
I don't have that tri-lines layer.
Okay, you can just type the name and it'll create it if you want. If you go to surface, it was only there because it was there when I ran it the last time, the first time we did the surface and I told it. But if you go to draw surface, draw triangular mesh. And I normally, like, I never draw the triangles in my drawing. It just adds unnecessary data. Unfortunately, it's making me pick a file now so it's got this lag going. Just a few seconds here. All right, so when I pick a file, see it comes up here. You can just type it right here if you want. If you hit select and you don't see it, you can also just type it down here and it will create it for you. Okay. And it doesn't really matter. I just wanted it to be an identifiable layer that I knew what it was.
Yep. Okay.
All right, now. So here's a couple of problems that we still have is these outside corner triangles that I don't want to be part of my model. Same thing down in here, these long skinny triangles. You see they're way across there, and I don't really know anything about the ground down there. So I could, now in terms of what's drawn here, I could just select those and delete them, but that doesn't take them out of my surface, right? So to be able to do that, we need to put a boundary around it. And it would have the effect of doing this. If I were to just draw a polyline, let's put this in, just call it BDY, just boundary. And I'm going to turn my snaps off for now. So, oops. So it would have the effect of doing something like this. Where's my cursor? And when I say it has the effect of, what I'm also suggesting is that it can serve the function as. Now I need to make that a closed polyline. So make sure that you have it closed. I'm going to come over here and change that layer so you can see it. Make it red and make it nice and fat. Actually, we'll make it yellow. All right, so if I select it, I see down here that yes, it is closed, because when I do the polyline and said, I got to the end, I typed the letter C to close. Now, oops, I could even do this. Put a little bit of an arc in there. And that's probably good enough. Now, remember what we did yesterday where we did that erase by close polyline? So we could do the same thing here and tell it to erase by close polyline, erase outside, and it get rid of these triangles and all that. But remember, the triangles were created from reading the surface. So the surface needs to have them taken out of the definition of the surface. And the only way to do that is to put a boundary around this thing and then go back and build the surface over again so that it gets included. I can't just add it. Well, actually I can. All right. But so here's a couple of techniques. If I go to, I'm going to, first of all, erase by layer, and I'm going to select from the screen. I'll get that triangle. So now they're all gone. So now this could be, and I could adjust this thing, because remember, all it is a polyline. And I could, you know, tighten it up and include a little bit more if I wanted. Something like that, you know, you get the idea. So all you have to do is, all you have to have is a polyline, and it can even be a 2D polyline. I'll bring this out a little bit further that away. Okay. And then maybe this one I'll bring.
I didn't get my polyline drawn outside of the perimeter. Can you walk me through that, please?
Yeah, I just drew a polyline and I just click, click, click and just drew it around there.
Just a regular 2D polyline?
Yes, sir. So I'm gonna come down here and grab a little more of this. Yeah, and it doesn't have to be exact. You don't have to worry too much about matching it up. All you're doing is you're saying, I don't want any surface outside that area. And so then when you build your surface, we go back to surface, triangulate and contour. Then what you would do there is you're going to say right here, you want to use an inclusion and an exclusion area. And then how do you want to treat that boundary? Do you want to trim the triangles where it hits the boundary, or do you want to remove the entire triangle that crosses that boundary? So sometimes you just want to get rid of the whole triangle, but we're going to leave it as trim at that boundary. Okay. And so now what it will do is when it creates all of these skinny triangles, because they lie outside of that boundary, it's going to get rid of them. Okay. And now also keep in mind, I can have 3 or 4 of these closed polylines. And when I tell it to use inclusion boundaries, it will take all of the ones that I say are boundaries and use them only to define the surface, and everything in between there that was not included would just be void. It would just be an empty space. So you might have a big site and you only want to get a little piece of it here as a separate boundary. Just draw a little polyline around it and make a new surface of just that area. Or if you're doing like phase 1, phase 2, phase 3, you can do those kind of things and make them even into the same single surface file, but you've got the different pockets of information. All right, so it's not just exclusively used to get rid of those outside triangles, but that's what we're going to use it for. All right, so I'm going to go back to surface, triangulate and contour. And this time I'm going to go to the contour tab and I'm going to turn that off because I'm not going to draw those anymore. I'm going to write the file and bear with me while it waits. So I'm going to call this EG. I'm just going to say width boundary. Okay. And I'm going to turn on to use that inclusion, exclusion areas. That means that my prompts are going to change. So be careful when you're doing this. So say okay. And it says select entities, but read the line above. It says select the inclusion perimeter polyline or enter for none. Note, or inclusion perimeter polylines. Notice it's plural. That's what I was saying. You could have more than one. So I'm going to select my polyline. I'm through selecting, so I hit enter. And now it comes back and it still says select entities, but now it says select the exclusion perimeter polylines. Well, guess what would be exclusion polylines? Like building outlines. We don't know what the contours look like underneath there. The canopy, maybe, but the ruins are just a flat slab. There's another building. There's another building. I'm probably forgetting 1 or 2 in here somewhere. Let's see. Oh, here it is. All right, so those should be my exclusions. Now I'm through selecting those. I'm going to hit enter to finish my selection set. And it comes back now and it says Select entity still again. And so now it says, all right, select the data you want me to use. That's where I'm going to come out here and grab this. And I'm going to finish that selection set. And off it goes to the races with those couple of little things we didn't clear up last time. I'll just say exit. And now let's look at the difference of what we have. Let's go to our view, 3D view, surface file viewer, and again, wait. And we're going to get EG with boundary. Notice over here on the right, there's a little preview area. And that shows me what that surface is. So I know I got the right one. I'll say open. And up it's going to go. I'm going to go back. So I don't like to see that as red. And you can set those colors, I think. Let's see, set colors, contour edge, surface, and they're set there. So the problem is when it's when you set it at one time, it tends to hold on to that. So anyway, there's my file. And now you notice all those long skinny triangles are gone, both on the left and down on the bottom. And I have these areas of no definition because there's a building sitting there. And so if I were to contour this one, see how the contours come up and stop at those buildings? Let me, they're pretty flat to begin with. It's hard to see that they're done. Let's see, let's turn. Yeah, there's a contour. See how it disappears into the building? If I didn't have that void in there, it would go in there, and then wherever it comes out on the other side, it would just draw it connecting across. Which is not the end of the world to have it do that, but you get the idea of how it works. But look how nice. You've got these curb lines, and you see the contours actually walk up the face of that curve, walk around the top and come back down and then come back around. So, here's another example. It comes across the island. Can you all see those lines, those contour lines? So it hits the top and then it walks down the face of the curve to the bottom and comes back around and then climbs back up again to the top. I don't know if you can see the contour lines or not.
I can see them. It's not the greatest, but I can see them.
Yeah, let me fix that to where you can. Let's see if it's something that'll. There's a little better. So you see, and you see that contour line hits the face, climbs the face of the curve to the top, goes back out around the top and comes back down. That's what we want. That's a well-defined surface. We look over here in our pond areas and it even picks up the thalweg of the stream coming out of here. So, we're pretty happy with this. And that's the same data that they used when they compiled this to deliver the file. Oops, let me get something like this. So it's a really nicely made surface. Okay, now here's another little technique that you could use if you didn't want to rebuild the surface, but you needed to add a boundary to it. is under the surface menu, there's a command called triangulation file utilities, and this has a lot of functionality to it. So we're going to load in a base file. So I'm going to load the 10 file, and as it waits for me to do that, I'm going to get that last one we made that did not have the triangles removed from it to show you how this works. And that was this one. See, it's got all the triangles included. So it's going to come in. I see it like that. It's much like the 3D viewer. In fact, you can even maximize it, but I'll just keep it down. And you can turn it on and off like that. You can roll it around with this little thing as well. All right, so now that I have this base in here, I'm going to do a couple things. Over here, I can pick a bounding polylines. So if I choose that, it's going to go away and let me pick the inclusion polylines, just like when I ran the command. So I'm going to pick that polyline. That's the only one I have, and I can hit enter to finish. Any exclusions, so I can go to here and here and here. And we did the canopy and this building. And then this building here. That'll be enough. And I'll say enter. And so now it has added those into it. And I'm going to go and I'm going to hit the next button down here at the back. And when I do that, it's going to go out here now. And I've got those bounding polylines. Let's see, it doesn't. And trim it out. Let me see here a minute. Pick that again. If something went. I was hoping it would exclusions. I was hoping it would show it to you before you get out of it, but apparently not. All right, so they're in there, but we don't get to see it for whatever reason. But I can come down here to the bottom where it says output, and I only want to output the inside. And if I save that as, come on. I'm going to call this one EG. I'll just call it trimmed. All right, so it saved it. I'm going to now exit. And when I view that one, well, that came right back. There's my trim, misspelled it, but. So now this was the one that happened, this is the one that happened from that triangulation file utilities. So that's a way that after the fact, if you don't want to go through, isolating data and stuff, you can add those in later. Unfortunately, you can't see the boundaries until you save it and tell it you want to save the insides because you've got the boundary on there and you couldn't really see it. But no biggie. It did the same effect. Okay. Now, One more technique, and I won't put you through the exercise, but just to show you how you can do that same issue or the same deal. I'm going to take this line and just make it red so that I can show you the difference. There's a command called shrink wrap entities under the draw menu. And it looks like a little birthday present, shrink wrap the entities. And this is going to let you, I'll put it on that same layer, to draw this either across gaps or with bounded lines only. So across gaps means it's going to shoot across the little openings between the ends of those lines. And there are 4 settings on how to do what's called a perimeter reduction. I'll explain that in a minute why it's called that. If I say none, let me show you what happens. And I'm going to say okay. And now it says select everything you want to shrink wrap. Well, I'm going to grab it all, but I'm going to type the letter R to remove, and I'm going to remove the one that I drew earlier, that red one. And I'm going to say enter to finish. And there is the outline of everything except for my red line. That includes all those points that were down here. You see these extra points. And it actually outlined everything and what happened. And when I said perimeter reduction of none, what it does when it builds this shrink wrap is it actually triangulates all that data in memory. And then it's asking you perimeter reduction. It means how much of these outside perimeter triangles do you want to get rid of? And I said none, so it kept them all, drew a line around it, and got rid of those triangles out of memory. Okay. So if I repeat that command, and this time instead of no reduction, I'm going to go all the way up to high reduction. So get rid of a lot of them. I'll say okay. I'm going to select all of this and I'm going to type R to remove, and I'm going to remove the one that we just generated and the earlier one that I drew. I'm finished selecting, I hit enter. And now you see this one. I'll make it a different color so you can see it. You see how it did? It got rid of all of those in there, but also jabbed in here and got rid of, even those little ones around the edges. Okay, so if I look at these, you see how the points are, and it's following the limits of those points. It didn't get anything in here because there was nothing in there. So it trimmed out everything that it could possibly trim out and still hold all the data. So that's the none, or that's the maximum. So I'll come down here and get rid of both of these. We'll run it one more time. And this time, what usually happens is either low or medium is a good value. I'm going to use medium. That's a good one to try to start with. So I'll grab everything here, R to remove my red one. And so now you see it's a little bit less severe, although it's still kind of jumbly up here, but it would still work. All right. Now that's by drawing that manually. And then when you run triangulate and contour, you would turn this on and it would prompt you to select it. But here's something even nicer that they've added to recent versions. If you don't have that on, it will shrink wrap all of this data for you, just as if you drew it yourself and then picked it. So it's going to go ahead and do it in memory. And again, I have those same choices, none, low, medium, and high. So if I say Let's do low, maybe make it not so convoluted at the top. And there's a setup button over here that if you choose it, you can choose either to draw it or not. I'll go ahead and draw it just so I can verify. I'll keep it 2D and I'll put it back on that same layer. And I'll say, okay. And now I'll say, okay. Is it okay to overwrite the file? This is, come on. I'll call this one EG with break wrap. And I'll say, okay. And now select the points and break lines because I didn't say use them. I'm letting it do it in memory. So I would just grab everything like before. I'm going to remove that red one there, although I didn't have to because it's at 0 elevation. And I'll hit enter. And off it goes. And the same error. There now is the shrink wrap that it did. You see it's not quite so jumpy up here at the top, and it also includes a little bit out in here that's maybe not defined. And if I were to look at that surface, which was the one with the shrink wrap, you can see, I'll go ahead and turn these contours off. You can see where it, display the triangle edges. So out in here is some of those that it did not delete that it probably should had, so we've got them trimmed off in the other ones. But you can see that there's a really nice way of conditioning that data. And it's not 100% necessary, but it keeps it from being a mess. And then when you draw your contours, they'll only draw out to that edge. So you don't need to, worry about keeping these. You don't even have to do that. You can let it create out there if you're not using it. But then when you draw your contours, you might have to trim them off and all that kind of stuff. So it's always best to put in boundaries around what you need. And especially if you've got 20 acres worth of flown data and you only need this corner up here. Well, and you could do one of two things. You could draw a perimeter around where you're working and say erase by closed polyline and get rid of all the other data. That's probably what I would do. Or you could leave the data, you've got it available, but when you build your surface, you're only going to work in this one area. And so you just put a boundary around that one area to build that surface. Okay. Now, let's put this back. I'm going to turn all my layers back on. And now I'm going to go to view. And I'm going to freeze layers by, oops, I say freeze. Yeah, freeze layer by pick. And I'm going to get that. Now, look at where you see how they trimmed their contours that they delivered inside the boundary? That's another technique that they use all the time, this particular company, is they compile out to the ends and then they trim it back. I don't know how, it was at 25 feet or something, that they trim off the contour lines, and that's all that they delivered, so that way they know that they've got some edge problems that they're not really going to worry about getting those put into place, okay? Now, here's that stupid cursor issue again. I don't know what's going on. Zoom. All right, so remember what we did yesterday on some other evaluation techniques. If I look at surface and do a quick profile down at the bottom section, the first command in the bottom section, quick profile. This time, instead of using screen entities, let's use a surface file, or we'll say surface file is going to be our source. Now, be aware, you don't just hit the OK button, because this always holds the last surfaces that you looked at from a previous job, even months ago, if that was the last time you did it. So you need to hit the first button and tell it which one you're going to look at. And I'll use my my one with my boundary. And where it says second, I'm just going to hit the second button and hit cancel. So it's only going to look at one surface. I'll say OK. And now it says pick a starting point, or use a center line, or draw a polyline and pick a polyline. So I'm going to just click across here. I'm going to click once and click over here and hit enter to finish. And that gives me that little viewer that I had before, okay, like right in here. And you can see now we're really nicely and well defined. We're not just going edge to edge, and like right in here, you can see the that little flat walking area that I was telling you about. And see, as I'm moving the cursor around, you see up here in the plan view, you can see right there, and there's that little curb line. You see those two purple curb lines, and it pops up on the curb and then goes across the flat area and then starts climbing the hill. Okay, but look at this. When you're looking at a surface file, one of the really neat things that it will do for you is if you've picked a point, you see the little marker up here. You see down below, we now have a button that says adjust alignment. So if I click that, and then I go up here into the plan view, and if I pick closer to the end point, it's going to lock the other endpoint down and let me move this around. And then when I click it down, it's going to put it back down. So I'm going to click adjust alignment again. And now if you pick nearer to the midpoint, look what happens. I'm moving this around and it's updating in real time. So if I want to come over here and look across my ponds, I'll put it down over there. And now I'm going to come back and hit adjust alignment again and get the other endpoint. Click it down so I'm more perpendicular. I'll do it one more time and grab the midpoint, and I'm going to slide back and forth. And now you can see up here, you see that little perched pond. You can see it in the profile as well. So I'll just put it down like right in, say, there. And now as I track, you can see where I am on the ground. And I've made that into a nice little tool to help me assess some different things. Okay, so I'm going to exit that, and I'm going to run that again. And this time I'm going to add a second surface. And the second surface I'm going to use is that original one that was bad. which was my original from Contours. Same thing, pick a starting point or whatever. So I'm gonna come down here. I'm just gonna pick a point, say along this road edge. All right, so now let's do a little fit. All right, so now you can see as I'm moving around in here, see that white line? There's that stair-steppy looking thing I was telling you about because you got those flat contour areas on the original surface. That's the red line that you see, that second surface. So you can compare the differences between. And that's looking down that one. If I adjust the alignment, I'll pick it up and sort of move it around. There's another spot right in there where you can see, you know, up here, we've got those stair steps. And let's do this one more time. We'll adjust the alignment. I'm going to come over here and go across in front of that loading dock area, which was like right in here. And I'll adjust the alignment to go a little more parallel to it. Then I'll adjust it one more time. And you can see that big ski ramp thing that we had there before. You see it showing up in the profile view. So it's a nice way to help you get a sense of the differences. And you can see right there, if you look at this in the profile view, that little chunk of dirt that it made, that chunk of surface that it made in this area, it ranges from about 1307 up to 1311 feet. So, you know, 4 or 5 feet tall. And that's way out there. If I get it even closer, let's see if I bring it up to, say, right in there. Oops, try it again. So now I'm between like 1309 up to 1317. So, you know, 6 or 7 feet tall in there. That's a lot of material. And your volumes are going to be incorrect if you, you know, if you model this stuff incorrectly. And nothing that we've done, I'll go ahead and exit this now. Nothing that we've done when we build a surface and we get the result and says, hey, you've got a surface, you know, and it didn't give you any errors. None of that would lead us to know that there's anything wrong unless we stop and evaluate this stuff and look at it. And that's the important thing to do, is to always look at these. Okay. Now, I'm going to show you one last little thing before lunch. And this is more for Cyrus than for anybody else, because you're going to hopefully recognize something here. When this was compiled, when the aerial mapping company did this compilation, their client was the Pennsylvania Turnpike Commission. And you should probably recognize this location. And I'll show you how we're going to do. I'm going to go to my GIS module. You probably don't have that, but I'm going to go to image now, and I'm going to place a Google Earth image. And it's going to ask me for a file here. All right, so I'm in my folder. I'm just going to call it site. All right, so now it says you want to pick from the screen or use a map, but that would load up into like an internet map viewer. I'm just going to pick from the screen. And I'll pick down here and I'll go up here, get it big enough to where you can see some things. And let's see, longitude is outside of the zone width. Oh, shoot, let me cancel that. Cancel. Let me choose my drawing setup. I may have not done this before. Yeah, I'm using Alabama. So I need to get that Pennsylvania South. Yeah, I'm sorry about that. All right, so now let's go back and do that Google Earth again. Come on. And I'll call it again, site. I'll pick it from the screen. That's from here down to here. And I'm going to just say, okay. Okay, so what do we have here is we have the site because this was done on state plane coordinates and it's loaded up here. Now, you zoom in really tight, you can see the Google Earth image is not terribly accurate and you can make that, a little better. But I don't know if you can recognize this, Cyrus, as to where this is, but this is that Breezewood interchange, like up here's the truck stop area.
Yeah.
And here's where it comes down and you take off up this way, up I-70. That's the on-ramp going up to 70 down toward Maryland. So there you go. So it's a nice little tool to use if you've got photography that you can load in and, see where you are in the world. And that's from Google. It goes out there and there's other sources you can use from different things. But anyway, that you need the GIS module to be able to do that, or you need to have some geocoded photography and you would just go to the edit image or draw, insert, or actually you would, the easiest way to do it is to just go to the Explorer like you're doing layers and come down here to if I can find it, they've moved these around. Where am I? Oh, XREFs down at the bottom. And then you would simply attach. And then when it comes up there, you would pull down here and choose an image file and load it up, just like a external reference. That's how you do it. In fact, if you saw that, or if you noticed that, I just saw it as I was leaving it right here. There's that image file right there, and I could unload and reload. So you turn it off and then bring it back, kind of stuff. All right. So that's about that. And when we come back after lunch, we're going to learn about designing some design surfaces using design pad to come up with pad and ditch and edge designs. And how do we do that? How do we build those into proposed surfaces? And we use that against our existing surface and see how it all ties in together. Okay. And we'll start on that little exercise that ties all this stuff together. Any questions anybody think of for what we've done so far? Everybody good? All right. So what I'm going to do, I'll go ahead and I'll stop the share and I will stop the recording. Lord. Now, let me get. Let's go in here. Some projects. Fundamentals. There's my data sets and there's the manual. Okay, so we learned about using break lines. In fact, a lot of the stuff that that we spent the morning going over, these evaluation tools, shrink wrapping your data, looking at stuff, adding break lines, things like that. That's all in that previous exercise. So now we're going to wrap it all up by putting everything together with not quite such a large data set so we can see how this is going to work. So let's go to our file. We're going to open a file called example1.dwg. Now I shut down absolutely everything, restarted my computer, the whole works, because I hadn't restarted it in several weeks or months, a couple of months actually. You get spoiled when you're using a Mac. Everything works until it doesn't. And then you gotta restart. All right, so I'm gonna open files and I'm here in my same folder, and this is called example 1. And we've got some projection state plane 83 east is currently used in this drawing. Not that it matters at all because those are just fake coordinates. All right, so when you get a drawing, it's going to look like this. And there are, as we can see, a series of points, some of which say B-toe. The others all say B. And we have no idea what that code B may indicate, but toe gives us a little bit of a clue. That could be our toe around the outside edge of this structure. So I'm going to do a couple of little investigations. I'm going to go to my file menu and I'm going to choose drawing cleanup. And I'm going to hit the clear button and I'm going to check my elevations here, set elevations outside the range to 0. And I'm going to say scan the drawing. So it's going to go through and scan the drawing and come back and tell me what is the minimum and maximum. And I see I go from 390 to 404. So looks like about 14, 15 feet total, and it's all in good shape, all about where I expect it to be based on the elevations of my things, indicated points. So I can just cancel that. Now, I'll also take a look at my 3D view. I'll go to View, 3D View, Drawing Viewer. It asks me to select my entities. I will do so. Finish my selection set, and I see, now you don't see the text and the labels, but I do see the points. And if I spin it up here by opening up my garage door, I can see that, yes, they are indeed at some elevation. I can also go to my settings tab and turn on this bounding box. And I see, okay, that's pretty good distribution. I think we're in good shape. with all of that. I'll now turn that back off and come back to my area here, and I'm going to go to the exit. I'm going to exit that window and come back out. So everything's looking pretty good in terms of something to get started with. Okay. So if I were going to build a surface out of this data, or if I was going to try to use these points for something, first of all, if you look at the descriptions on these points, what do you see? That there's basically two descriptions. So we could, how could we maybe eliminate these to, let's say if we only wanted to look at the toe points and not the other points, what's a quick way of doing that? Might be, remember our point groups that we used? We created our point groups. And so,
Yep.
so let's go to the points menu. Let me switch back to my survey. And let's choose point group manager. It's the last command in the top section. And it wants to know, well, what coordinate file do you want to process? Well, gee, we don't know, right? So I'm going to, this is called what, example 1. So I'm going to give this a different name. This example 1 that we used before, that was another set of points. But let's choose the new tab instead of existing, and let's give this a file called stockpile, because that is what that thing is called a stockpile. So now I want to create a group. So I'm going to create a group, and let's call this the boundary. And let's include all. We're going to uncheck. And then if we say description and say set from a list, if I choose that, you see there's nothing there. Now, why is that? I can say set by selection, and if I choose that, all right, it reads that one. But why didn't it find it from my list? And the answer is there's two different things going on here. One is the list is reading the coordinate file that I just told it I wanted to use, that stockpile.crd. But there are no points in that file. There are only points in the drawing. So I need to figure out how to get these points from the drawing into my coordinate file. So we're going to see if this is going to help us. I actually don't know the answer if we can do it this way or not. I'm going to give it a try. So I've got my B toe as a description to use for my point group called boundary. I'll say save. And I'm going to make another one called interior. And I'll uncheck include all. I'll check description and say set by selection, and I'll pick one of the inside points, and that's the B, and I'll save that. All right, so there I've got two groups with a definition, but no points in it. All right, so how do I get these points? I could go to these things here, and I see there's nothing really that I can do. I don't have any points because this is all working on the coordinate file. I was able to snag the descriptions okay, but I don't have any points. So I'm just going to say, okay, or if I import, yeah, I can't import from another file, and I can't import from this. So I'm going to say, okay, and now I've defined my groups. But how do I get those points from the drawing into the coordinate file? And the answer is, and we haven't gone over this part yet, but it's really quick and easy. It's on our points menu, and you can do it two ways. You can go to the point utilities, which is next to the last in the points menu, and you can say update the coordinate file from the drawing along with all these other kinds of commands, okay? And you remember the other day when we were talking about the linking of the line work with the points, and if you moved the point, the line went with it, and if you didn't have it on and you drew the line and you moved the points and it stayed put. Well, there's a command right here that links lines and polylines with the points so that the line work will update if the points are updated. So even if you created it with that off, you can manually turn that on after the fact if you run that command, okay? And you can see some of these other things it can do. You can search a file, you can trim by a point symbol. Instead of using a wipeout, I like to use the wipeout. So anyway, these are all the things you can do with these point utilities, but there's an even easier way to do that. And there's a little icon for it that looks like a Swiss Army knife, and this is called coordinate file utilities. And this is going to run a bunch of commands all from one location. And it tells up the top which coordinate file you're going to use, stockpile.crd, or if you need to switch it, you can choose open. Now notice the command list is divided into two columns. The column on the left have to do with things that work wholesale on files, like importing coordinates from another file or exporting into another file. You can convert the file format into different programs that use different formats. You can do all of these different kind of things. Edit a file header, compress it, so get rid of the empty gaps between numbers if that was what you wanted to do. The other column are things that work on anywhere from a single point to a selected group of points. So you could assign descriptions to a bunch of points. You can align them to different things. You can translate them, erase them, do a report on your point numbers, renumber your points automatically, and work on this point history if it's saved, et cetera, et cetera. All right. But the one we're after is these two down here at the bottom. You can either update the coordinate file from the drawing, or you could update the drawing from a coordinate file. And what that does is if you have points in one or both of those locations, and maybe they're in, both of those containers, one coordinate file, one drawing, then you can synchronize their locations based on whichever one you're going to do here. So obviously we're going to choose update the coordinate file from the drawing. So I'm going to choose that. And it lets me, I could put in a wildcard description. I could put in there like B-tow and only get those points, but I'm going to go ahead and take all the points. These are the attributes that are going to be used. And because that is what this block is consisting of, those three named attributes. And I'm going to say, okay. All right, reading my prompts now. It says select Carlson, Land Development Desktop, Soft Desk, Inroads, Eagle Point, Geodometer, Leica, or Micro Survey Points. So it's expecting 1, 2, 3, 4, 5, 6, 7, 8, 9 different formats of points, although LDD and Soft Desk use the same point format. So it's expecting to encounter those in the drawing, and then it's going to use those to put into the coordinate file. So I'm just going to zoom back out here. This is all I've got in my drawing. I'll just click, drag my window around it, click. It still says select entities, but I'm through building my selection set. So I hit enter, off it goes. And it tells me down at the bottom, it tested 240 different entities and it found 80 points. Now do the math. That means there's 3 entities in each one of those points, and there is a block that is the symbol. There is a block that is the set of attributes or the labels, and there is a CAD point. So that's the 240 different entities it found, from which it extracted 80 points. And now if you want to make sure that they're in your file, just come up here and use this command list points. And it's just like the command that we used yesterday when we were working with points. We'll just list the points. So I'm going to uncheck the formatter, and I'm going to just say report the range. And I'll say, okay. And there I can see, well, I've got points 2000, 2001, blah, blah, blah. Goes down to 2028. with B dash toe, and the rest of them are all B points. All right, perfect. I've got them in my file now. And to verify, if I go back to, I'll exit this now. I'm going to go back to my points group manager. And whoa, look at there. Indeed, they are there just based on the fact that they live in the coordinate file and they have those descriptions. That's how these groups are going to work. Okay. So now, even if you were to erase everything in here and get rid of it, like this, I'll just select it all and erase it. The points are still in my coordinate file. Okay, and I can always come back and redraw those points. I'm doing this here too. One of these days, I'm going to fix this so it's automatic. All right, so I've got a bunch of points in coordinate file, nothing here in my drawing. So I'm going to go to points, draw locate points. I'll choose whatever symbol I want to use. The X is fine. And let's make sure we have on descriptions, elevations, point numbers, loci and real Z, and V node. Let's put these on V dash node, V meaning survey, node meaning point, D dash node dash boundary, BDY. And I'm going to draw my point group by choosing the point group button of boundary. Say, okay, boom, there they are. Okay. Next.
For some reason, for me, I don't have the points in the boundary. I have it for the interior, but not the boundary.
You in your point groups.
Yeah. Yeah.
So if you go to points in point group manager, do you have two different groups?
Yeah, I have both groups, but the boundary doesn't have any points in it.
All right. So if you look at interior and you scroll that down, is it only B's?
Yes.
Okay. And you go to boundary and there's nothing in it, right?
Nope.
Okay. So we can fix that real quickly. All you have to do is edit that definition. You can either select it and choose the edit button or just double click it. And it brings you right back up to this. Okay. Now, how was that built? What's checked on and what's not?
Mine doesn't say B toe at the bottom. That's probably why.
Yeah. So I don't know what it might say, but you can just, whatever it says, if there's anything in there, you can highlight it and retype over it. Just type B-TOE, or you can even set by selection or set from a list now, which will work. And you can come down here and just find, and all you need is one of them to tell it what description to use. And when I said set by selection, that's when I went out and got it from the drawing where it's
Okay.
set by list. Okay, so did that work now? Go ahead and hit
Um,
save. And then when you come back into this, you should see them.
I don't see it still. Let me by
All right,
selection, maybe.
go back to edit this boundary group. And where it says description, choose the button set from list and scroll through that list and tell me what descriptions. You should see both descriptions in that list.
Yeah.
Okay. So
I clicked on it and saved it, but for some reason it's still not coming up.
clicked on that and said, okay. Now, are you on the include tab or the exclude tab?
The include.
All right, you're on include and you got checked on for description, not any of this stuff. Right.
There, I got it. Never mind.
Got it?
Yep. Thank you.
Must not have been holding your mouth right when you did it.
I don't know.
All right. So now those are points on a layer called V node boundary, and they're my boundary points. So I'm going to go back to points, draw locate points. And I'm going to do the same thing, except I'm going to change from V node boundary to V node spot or spots, just spot shots. And I'm going to draw a point group. And this time I'm going to do the interior points. Let's say, okay. And now there they are. They look just the same. But they're actually on two different layers. And in fact, if I go to my layer manager, now the reason they came in looking red was because I was sitting on this layer called final that was red. And when I ran the command and told it these layer names, it created them for me. I didn't have to build them, but it inherits the same characteristics of the one that I'm sitting on. So if I want my boundary points to be red and say my interior points to be green, all I have to do is that. Well, actually, I would need to redraw those points. I think that'll do it. These spots. Interior. Oh. Actually, no, the points are not going to change. It's this point mark. See these three layers right here? These are the layers of the attributes. There is a point number, so that number is white. So if I made that say yellow, now watch all the point numbers change to be yellow. See? So if I wanted to change that symbol, point mark, instead of being red, if I wanted it to be, say, magenta, there we go. But it does all of them because they're all sharing that attribute, are all on P&T MARK. Now you can do that. You can make them look different. I'm not going to get into the weeds on this, but when you do a draw locate point, if you do this, there's a it's not on this one. It's on, I go to points, my point defaults. Let me see what that does. Right here's where you can set that layer for the points as well. But over here's where it is. There's separate layers. Okay, so you can say points, symbols, or both. And if you said, say, just symbols, and then I'm going to repeat those commands. I'm going to draw locate points. I'll do spots again, draw a group. It's going to be my interior points. And if I repeat the command and do it for boundary, draw a group, my boundary points. All right, so now when I select it, it's grabbing the whole thing. Let's see how it says the layer varies. Because there's a block. And I told it to separate out those different layer names, which you can see right here. We still have these original ones that we had, but now we have V node, boundary, and boundary mark. So the boundary mark layer, let's make the boundary, we'll keep it red. But the spots mark layer, let's make them yellow. And it's still not changing. Oh, all right. Well, anyway, you get the idea. Let me see if I freeze. Um, I do that again. Let's see. Spot mark. Well, go back to my point default. I'm going to I'm not going to separate the layers. I'm going to go back to just having them all there, and I can just choose the whole layer by itself. All right, now. I draw a locate point. I'll put them on B node boundary. I'll draw my boundary points. Do it again. B node spots, draw my interior points. There we go. So now if I freeze off those layers, it can freeze the whole point, so you can turn the points on and off if we need to do that. Now, so we're going to basically build a surface out of this. So what, if you're looking at this data and you know you're getting ready to build a surface, what's one of the first things you're going to think about? What would be a limitation or would be something that you might want to control? Remember I told you when the data has these little ends pointing, these little concave areas, it's going to start to put triangles around those.
I was gonna say break lines,
Yeah, so, well, yeah, I mean, you would want some break lines,
contours.
but you definitely need the boundary on the outside. Otherwise, you're going to get these long, skinny triangles out here in these concave parts, okay? In fact, it would look like this if I were to do that, which we won't, but if I'm going to shrink wrap with no reduction, see, that would be what my surface would look like. So up in here, even though I don't know anything about what's going on in here, my surface is going to be defined out there with those long, skinny triangles. So what I need is something that does like this. So if I need that perimeter to be, you know, going into all of these B toe points like this. No, I'm not going to go all the way around it, but see, that's what I need is I need that boundary to wrap around this outside edge so that I don't have those things out there in the undefined space. So number of ways to do that. One, you can shrink wrap it and set, instead of none, you might set it up to be high, but you're running into some dangers there because here that one worked, that one worked, that one worked. There's no guarantee you're going to catch all of them. I think there was, yeah, here's an example. Right here, it went from toe to B to B to toe. So I would really need, in this case, to come in here and delete those particular vertices. You see, so that's, you know, and this is a very simple data set. So don't get hung up on it. It's not like it would be hard to do that. But we have something already in our favor. And if you look again, let's go to points and look at list points, and we're going to see, I'll just say all. We see we start with point number 2000, and they're always in numerical order when I list them. And I see I've got all the toe points. They go from 2000 up to 2028. So that gives me an idea that maybe they're all in order. And the rest of them then are from 2029 down to 2079. So if I look around here and see, okay, here is point number 2000. I think that was their first one. Yeah, here was point number 2000, 2001, 2002, 2003, 2004. So I can see that it does go all the way around to 2028 was my last one. So maybe I'm going to do that. So I'm going to draw a 2D polyline. So I'm going to my draw menu, draw 2D polyline. I'm going to also put this on a layer called BDY. And I'm going to say, okay. Now, it wants me to pick a point or a point number. So remember, with point numbers, I'm going to try my luck at it and see if it works. 2001-2028 and hit enter. And boom, there it goes. And now it's still in the draw command. See, I still have the command up to command line. And I look this over and I see it start at 1, 2, 3, 4, and it goes all the way around and doesn't cut back on itself and doesn't jump into any of the B points. So, hey, that's a pretty good solution. Now, to make it close back and make a closed figure, I could type the number 2001, but that doesn't close it mathematically. But one of my options down here is C to close. So if I type C to close, it will close it mathematically and finish it. I now have an enclosing boundary to do my work with. Okay. So,
You're missing that 2000 vertex point.
okay, one quick second. Ah, okay. I see what you did. I just started the wrong number. I should have started at 2000, not 2001. So to fix that, I could come here and just add a vertex and just go up to that point. Okay. So good eye though. So you could do that. There's another thing that I want to show you that you can also do, and that you can draw polylines. So if I go to the draw menu, now that was a 2D poly, 3D poly. That's what we use most of the time. But if you come down here and see draw polyline, you can do by nearest found, do a 2D. We'll put this also on boundary. Maximum separation. So you can give it the biggest gap that you're going to allow if you want. And now it needs a description match. So I'm going to say only consider points with the -TOE description. And I'm going to say, okay. And so it's now going to work by number or by point number, but I can just go out here and select them. So if they weren't in order, I could do this and it's going to go through and draw them up all the way around here by the nearest one that it finds of that description. And it looks like it all worked just beautifully, except what's not apparent here or what didn't happen. If I select it and look at my properties, what do I notice? It's not closed, right? So I'm going to just change that property to be closed so that I can use it for my boundary. So if I were to build this surface using that as a boundary, I would have to then go and select those points because remember, this is a 2D polyline and it has an elevation of 0. But here's something that you can do as well, is if you draw that line as a 3D polyline, so I'm going to draw polyline by nearest found. I'll make it a 3D polyline. I'll say, okay. From the screen, all. And now I need to close that again as well. Okay, so it's there, but the difference now is, as you can see, it's followed the elevation of all those points. You see that? So now, because of that, when I go to build I'm going to need to build two surfaces. I need to build a surface for the bottom of it, all the way just edge to edge across the bottom. And then I need to build a surface that goes and includes all of these points in the top. So this bottom edge to edge is going to be like my existing ground, and these points in the middle are going to be my proposed ground, and I could compute how much volume is in this stockpile. Okay. So, you know, because this this line is not flat, it's not sitting on level flat ground. You know, some of you folks like in Iowa and Texas, it might be darn close, but you know, we have stockpiles here on the sides of mountains. So the reason I did this as a 3D polyline this time instead of a 2D is so when I use that to build my surface, all I have to select is that single line. I don't have to go here and find all of those points to build it. I'll just use that line. Okay. So now let's build that surface. So let's go to the surface menu and choose triangulate and contour. And the first thing I'm going to do is on the selection tab, I'm going to make sure I don't have anything selected. So I'm just going to pick my stuff. So I'm going to go back to the triangulate tab and I'm going to choose the select button for the file. Well, that helped. It came right up. So good. So I'm going to call this SP dash bottom. So stockpile bottom, right? I'm not going to draw any stuff here. I'm not going to shrink wrap. I'm going to use the inclusion exclusion areas. So I'm going to pick the line. I'm also going to use it as my data. So I'll ignore any zeros and nothing else checked. I'm going to go to my contour tab and I'm going to leave the draw contours unchecked for now. We'll come back to that in a minute. And I'm going to say, okay. Now it says, okay, select the inclusion boundary. There it is. I hit enter to finish. There are no exclusions, so I hit enter. Now select the points and break lines to triangulate. So this time, because this point has elevation, this line has elevation around it, that's the only thing I need to pick, and it would be just as if I selected all those points. So I've got that selected. I'll hit enter. Boom, there it is. Verify that by looking at that surface. There's my SP bottom. And it made these giant triangles, and they look, you can see it's fairly flat, but you can see around the edges, there's a couple of little turned up corners, and, you know, maybe one of those points might not have been exactly on the ground, like this point right in here, you see. Okay, but that's what we got. And that's good enough for what we're doing. Now, we could, you know, fine tune all of the different things in there and add some stuff to it, but we don't need to. Now, I'm going to see if I can do this for a minute. Let's say by, yes. All right, so now I want to use that same boundary, but I want to use these points, these interior points, okay? And I can even use these exterior points, it won't hurt it. But I'm going to make the top of the stockpile. So it's going to go from the edge of the boundary and up to the interior and back down to the other edges. So it's going to match all the way around the edges. But the bottom surface is basically flat. The top surface has the top part to it. So let's build that surface. We'll go to Surface, Triangulate and Contour. The only thing I'm going to change on the Triangulate tab, I'm going to choose the Select button, and I'm going to call this one SP Top. Okay. And here's my inclusion polyline. No exclusions. Now select what you want to triangulate. Now this time I'm going to take everything. Okay. Wrote the file. I verify it by going to my viewer. There's my top. There's the bottom. Let's look at the top. And so now you can see that it actually does have some elevation. In fact, I'm going to give it a little vertical exaggeration here, maybe 3 times. So you can see. And I can tell that, there's probably a bad point right there. Excuse me. So, but I'm not going to chase it down. All right, so we've got our surfaces. And oh, excuse me. Oh, by the way, if I looked at that again, oh, sorry, let's turn these triangles off. The contours on. There's 1 foot contours. And then if I add the bottom to it as a separate surface, now you can see how that happened. And you can see right in here, there's going to be a little discrepancy. There's where the bottom pokes through the top, because there's a point in here that the top used that the bottom didn't, and that pulled it down below that surface. All right, no big deal, but I only wanted to show you this because when you do when we do our volume calculations, we do our volume report, the difference between those two, or we're looking at cut and fill. So it should be 0 cut and everything else should be in fill because it goes from the bottom up to the top. The problem is, excuse me, that there's this point right in here, and maybe maybe another one. I think it's just that one point. Yeah, that is sitting, at a lower elevation than that one edge. So there's going to be just a wee little bit of cut involved to go from the brown surface to the green surface. Because if I turn that brown surface off, watch, see how it's, and then if I turn the green off, you see that goes straight across, but it doesn't pick up those little points right in here that are lower than the ground surface. All right. So, so when we do our volumes, we'll just know that, part of our report is going to be slightly different. So again, if we're out on a job site, maybe we're working for a quarry or something, and or a coal company, and we have to figure out how much materials in a stockpile, and we get our drone mapping back and we build our surfaces. And so we're going to go to the surface menu. And now what we want to do is to compute some volumes. Now, those of you that are, those of you that have civil, for instance, well, I'll switch over to the civil menu or civil module for a minute. The civil module, excuse me, gosh, has this command right here to compute stockpile volumes. But it's really nothing in the world more or different than what we're doing right now. It's just couches it in a little slightly different terms. And it also gives you the option, instead of building the bottom surface, you could tell it to just calculate the volume above a particular level or a particular elevation. So, excuse me, it's to my way of thinking, there's no need to have made that as a separate command. But, some customers somewhere along the line called up Bruce Carlson way back when and said, hey, what'd be cool is if you had a little command, because that's all I do all day long is calculate stockpiles. Okay. So that's that. But we're not going to worry about that one. We'll switch back to survey. And let's go to surface. And now we're going to compute some volumes. And we've got right here, volume by triangulation. And we're going to use, now here's the way the stockpile system works. If you do a 1 triangulation surface volume, how do you compute the volume of a surface? If I do that and I choose my top, this is how it computes it. So it can either say, give it a starting base elevation, and you would type that in, assuming you're sitting on level ground. Or you could say, use the 10 perimeter. And so it would take that surface and it will walk all the way around the edges of it and extract the elevations of it and use that as a surface. And so I'm going to say, okay, you can put in shrink and swell factors, cubic yards, cubic feet. You could use tonnage. Let's say I'm using limestone, 120 pounds per cubic foot, and do all these different things. I'll say, okay, and there's my report. And I'm going to dump it off here to the screen. And I'll come over here and exit. So this was a one surface volume, and I'm doing this to show you the numbers. Now, right here is that little bit of upturn on that corner, that 1.7 cubic yards, okay? Up here in this corner where the points on the inside are below the average elevation. All right, so I'm going to repeat the volume calculation. Go to surface, volumes by triangulation, but this time I'm going to use two surfaces. Now, this is what you would normally do when you're computing your earthwork on your projects. You're going to use the bottom surface as the existing grade, and then you use whatever, other surface you have as a final grade. So it's going to, now we're just going to pick a surface file, but look at the top stripe up here. It says select the existing surface. The reason I want you to get used to looking there is because once I do that, my existing surface is this stockpile bottom. When I hit open, it's going to immediately come back with the same dialog box. I said, oh, well, I just picked it. No, now read the stripe. It says now select the final surface. So my final surface is now top. Now choose open. And it wants me to now, do I want to select an inclusion polyline or press enter for none? Now I don't need to use one now if I'm going to be using the entire extent of the surface because it only exists out to that perimeter. But maybe I've got a 5-acre surface and I'm only interested in a particular area of that, and I can just draw a boundary around it and choose it. You get the idea. So I'm just going to say enter, no exclusions, and report. I'll keep everything the same here. I'm going to say okay. Here's my numbers, and I'm going to say now output to the screen. I'll do the same thing, and I'll just pop right down below it here, back and exit, and now let's compare. So here's one where I used the hem of the skirt, if you will, 1.7 yards of cut, that little bit of upturn, 32, 65, 55 yards of fill. What are my numbers down here? 1.7, 32, 65, 55. So they are exactly the same. Okay. So it's all the same technique, the same computation. All right. Now there's a couple of things to consider in here. If you're doing also two surfaces, and don't think about a stockpile right now, think about, maybe a design job you're working on. There's a couple of things that are coming out of this set of numbers. It tells you the area that is in cut, just 188 square feet, not very much. The area that's in filled, 25,000 square feet. But then this block here in the middle, these 5 lines, this is taking these numbers and that area and the amount of volume, and it's calculating an equivalent cube. And it says, all right, on average, you have to raise 3.53 feet of fill to make that volume happen, which means you would have to bring in 3,263.9 cubic yards. That's my import volume, okay? My elevation change to reach a balanced condition would be is if I dropped that height negative 3.5 feet. You see the average fill depth? Because that little bit of cut, that's why the numbers aren't exactly matching. But so it's saying that if I take an existing ground and I've got a building pad and a parking lot and a driveway and I come up with these volumes and it says, hey, you've got 28,000 yards of fill you got to haul in here. But if I look at this number over here, it's going to tell me with this number right there, the 3,000 or the negative, whatever it's going to be, that's how high I need to raise my site or how much to lower my site to come into an even condition so that it's balanced. And here's the other cool thing. This volume change per 0.1 foot of height. So every 10th of a foot that I raise or lower my site is going to account for 93 cubic yards of materials. Okay. Why is that number important? Well, here's a classic example. I was working on a project up in upstate New York for Lockheed Martin, and the uh, the site architect for Lockheed, he was in charge of that. We were building. They were getting ready to build a new helicopter hangar facility on the property, and it was going to be where they fly in the new Marine One presidential helicopters. They fly in the empty frames up from Texas, and they fly them up to their facility there, and they put them in this high security lockdown 8-bay helicopter hangar, and they strip out all of the basic components and they put in all the high security avionics, and they turn it into the president's helicopter, in other words. So it was really a showcase project. And the architect, so anyway, where we decided it was going to be placed on the campus was at this particular location. And we did all kinds of, grading, and we had to worry about wetlands incursions. And if we wanted to build a bridge across the wetlands and the stream, and it was going to cost X number of millions of dollars and blah, blah, blah. And anyway, we got it sitting there where it was supposed to be. And the architect for Lockheed looks at it and he goes, we did some mock-ups, and he looks at it and he goes, as you're driving in from the main road and you're coming up the entrance road, I'd like to be able to, this is really a showcase building. Can we raise that up, 2.5 feet? Just 2.5 feet will get it up a little higher visibility. You can see it from further away. And the contractor was in this meeting, the guy that's in charge of moving all the dirt around on the site. And he said, yeah, sure, we can do that. Just 2.5 feet. You want to raise the site 2.5 feet? And he goes, that'll be, $4.2 million more money. And the architect just about had a cow. He goes, just to raise it up 2 feet. He goes, yeah. And because the contractor knew this number right here, he knew how much I'm sorry, he knew this number right here for our site. So 2.5 feet is 25 tenths of a foot, right? So he knew whatever that number was, whatever this number was per tenth of a foot. Let's say, I don't know, maybe it was 8,000 cubic yards, whatever it was, a significant site. Well, he just multiplied that by 25, and he knows how much money it takes to move a yard of dirt. And that's where he came up with the $4.2 million in the meeting. So, it's a nice number to know. And that's what's nice about this volume calculation, is that it computes that equivalent cube of information. All right. Everybody with me so far? Okay, let's move ahead now and do some more work. If I needed, let's see, I don't really need my points in here anymore. I can either freeze them or you can even erase them. I think I'll just freeze those layers. I'll go to my layer manager. I'll find that V node boundary and spots. and I'll just freeze them. So the points are still in my file. They're also still in the coordinate file, but I no longer have them plopping around. All right. So what do we have here? Let's see what it looks like from a contour standpoint. So let's go to our surface menu again. Remember, I told you I never draw my contours till I get my stuff finished. So I'm going to go to surface, and now I'm going to say contour from tin file. And the tin file I'm going to use is that stockpile top. Notice this command comes up, and it's exactly the same as the other except, well, not exactly the same, but it doesn't have the selection tab because we're not going to be using any data. And I'm on my triangulate tab, and I'm just going to, there's no need to even use inclusions or ignoring zeros because I'm not calculating, I'm just drawing the contours here. So I don't need to restrict that surface to draw these contours. So I'm going to go to my contour tab now and turn it on. Okay. Now this time I'm going to go up to my contour layer and I'm going to type EG dash in front of that CTRINT. So it's going to make a layer called existing ground contour intermediate. And I'm going to come down here below it and I'm going to say EG dash in front of that one. That's going to be the index layer. And I'm not going to use any smoothing. Excuse me. Now I'm going to go to the labels tab and I'm going to label. Well, I put the index contours on EG, CTR, IDX. I'll put them on the same layer. So I can freeze them on and off if I need to. I'll use this label style of standard or whatever I happen to use. My index label layer is if you needed to go on a different layer, we do the same, or you can use the contour layer as a prefix, all kinds of controls. But the key thing I want down below is I want to label the index only, align it with the contours, draw it on the real Z, and I want to hide the drawing under the labels. And now I'm going to use a distance, or if I'm plotting it, let's see, my must be a 20 scale. So yeah, say every six every 6 inches should generate a label. So I'm going to say okay. And boom, there it is. There it happened that quickly. All right. Now, if I were to repeat that command, you see how sharp and jagged those things are. And this time I'm going to go back to triangulate and I'm going to, or I'm sorry, contour tab, and I'm going to turn on Bezier smoothing and I'm going to crank it all the way over. And I'll show you the difference. I'm going to look on my triangulate tab where it says erase previous contour entities. I'm going to say all. And I'll say, okay, boom, there it goes. So now look how much smoother, but see, here's the danger because that surface doesn't actually do that. This is just a smoothed representation, okay, to make the contours look a little more pleasing. And here's another way you can check that. Go to your surface menu and you don't have this in civil. That's interesting. Oh, well. I mean, you don't have it in survey. In civil, we have this thing. I'll just show it to you real quick. You've got a surface inspector. And so we're going to be clear of that. And we're going to call this just SP for stockpile. I'm going to set and choose my surface. And now when I hover the mouse, notice this thing is going to track my cursor. And you see how the elevations are changing as I move around? So if I'm sitting right on that contour, that's at elevation 398. But notice, see, it should be 398 right in there, but it's not. It's 397.9. If I come out over here, I don't get to 398 till right in there. Okay, so that's because those contours were warped as it was doing the smoothing. So I'll go back again one more time. I'll switch to survey and I will contour from 10 file. Very same thing I've done before, except I'm going to now turn the smoothing off and say, okay, boom, there it is, back to having the sharp edged contours. And now they would match exactly. And that's fine with what we're doing. But now, notice this. Let me see what. Let's go to the settings menu and use drawing setup. And let's change it from a 50 scale drawing to a 20 scale drawing. And I want my symbols to be 1/10 of an inch. And my text to be 1/8 of an inch or 800th of an inch. And I'll change that line type scale to 1 and cancel that and choose a grid system, no projection. And we'll say, okay. All right. I'll save my file. And now, because I've changed those sizes, I'm going to go back and recontour that again. Let me double check my size of my labels. 0.08 and that's fine. Say okay. So now you see they're much more attuned to what they should be. All right. Now, what do you do with a case like this? See how that lands in the corner there and it's sort of inconvenient and not really lined up very well. Now you could pick that up and move it around and rotate it to match the contour line, but there's a much easier way as long as when you draw the contours, you say hide drawing under labels instead of break at that spot. If you've just done the hide, this command will now work. Go to surface, go to contour utilities, fourth one down, go to the right, and down at the next to the bottom, it says move the label along the contour. Select that. It now asks you to select the contour label that you want to move. So you just pick it. And now it actually walks the contour. So if I wanted to move it up here, it walks it, rotates it accordingly. I'll move this guy up, say into this area. And maybe this guy up there a little bit. So that's now nice and spread out and readable. And it did not label this one because we gave it a minimum length. And let's see, maybe let's take that and put it, say, just right there. All right. Then when you're through moving those around, you can hit enter and be done with it. Okay. So something that's pretty nice to be able to do. Now, let's look at how do you actually create like designed surfaces and things of that nature. You know, right now we've been taking things that have already been drawn in the drawing for us and building a surface out of that. But what if we wanted to, let's say this is our existing ground and we're going to build a, oh, I don't know, a building pad or a parking lot or something along those lines. So here's how you would go about doing that is you are going to draw some things in the system and give them elevation, and then use the elevations of those drawn entities to create those surfaces. But then there's a command that we use to calculate or to how we use it to tie down into the existing ground. So what we're going to do right now as part of this example is you see this 400-foot contour, then that means there's 395. So it falls downhill this way and it keeps going uphill this way. So I'm going to put a little pad right here in the middle at about, you know, a 399, 399.5, some kind of elevation close to that 400. I'm not going to use the actual exactly 400 because the contouring gets confused because it's trying to contour the entire surface. So here's what I'm going to do. I'm going to go to my layers and I'm going to create a new layer and I'm going to call that pad. And let's make it green and we'll give it, let's say a 0.25 line weight. And now I'm going to double click it so that that's my current layer. And now I'm going to draw a 2D polyline that's going to represent this pad. And I'll just click to use my current properties. And let's say, oh, let's see here. Show you another little trick on that 2D polyline. When I'm drawing this, I've got another checkbox up here, and it would be wise to keep your eye on this from time to time, because if you use it and forget to turn it off, it can be problematic if you don't intend to do it. But there's a switch right here that says auto connect for 90-degree corners. And so if you're drawing, say, something that you expect to be square-ish, you can use that to guarantee it's square without having to worry about, you know, turning ortho on and all that kind of stuff. So I'm going to use that. And now it wants me to pick a point or a point number. So I'm just going to come down here, say, pick this point, and I'm going to go up here. And so now, and I don't know what the tolerance is. Like if I were to go way over here, it won't automatically correct that. But as long as I'm within a certain tolerance, whatever it is, see how it jumped, how it moved to make it square? Same thing if I come down this way. I'm going to come over here and find that. See, I can't project it yet. It doesn't have enough to project my direction. Okay, no biggie. So I just come over here and wait, close enough. There it is. And boom, I'm done. Now, I didn't jump back up here because it would not guarantee that it would meet at that same corner. But there's a way of doing that. And that's to extend this one. And then, you know, they're going to meet at the intersection. So I'm going to basically select this, do a grip edit. And because I've got my projection mode on, see how that goes that way? I'm going to project up to that on that line. And then I'm going to hover on this endpoint and I'm going to get that projection. And now where the two meet, I can get it to start. There's that projection. And then Almost had it. It's very sensitive today. Well, let's just do it another way. I can fillet that with a 0 radius curve. That would do the same thing. So if I go to edit and I'm going to come down here and do a fillet, that's typically used to put an arc between two line segments, but I'm going to use it the same way. And I look down here at the bottom of the screen and I see that its radius is set to 0. If I wanted to change it, I would choose radius and type that number. So I'll leave it at 0 and I'm going to click this line and this line. It's the same line, but I'm going to click it and it's going to close it up to meet at the corner. Okay. Then I'm going to verify when I select it. I'm going to look down here at whether or not it's closed. Yes, it is. Okay, good. That's what I want. All right. So now I've got a closed pad and it's sitting here. I'm going to just select it, maybe move it a little bit further that way. And I might want that to be at an elevation of 399.5. So with it selected, I can come over here to the elevation and type 399.5. Okay. So now there it is. And if I look at all of this stuff in my 3D view, let's go to my view, 3D view, drawing viewer, not the surface now, but just the drawing. And I look at that, I spin it up, and I see it sticks out on the front side, and it's below it on the back side here. See, can you see that? Let's see, maybe an easier way. Give it some ginormous exaggeration. Now you see how part of it sticks out the front and it's over the ground, and part of it's underneath. Okay. So that's what I want. That's my building pad. So now how do I build that and tie it into this existing ground? Okay. And that's going to be on the surface menu. There's this thing called Design Pad Template. And that's going to be what we use all the time to design this and tie it into the ground. So, and Civil had the Civil module, I'll show you that in a minute too when we get to it. But if I do a Design Pad template here, now here's what's going to happen. We're going to fill this out the way we want. We're going to say, what is the target that I want to use? I'm going to target a surface file. That's that top. That's what I'm going to tie to. Now, which direction, if it's a closed pad, which mine's closed, so which direction am I going to target? And if you know, when you get into doing this one at home, in fact, I think I'll leave this exercise to you maybe. You see how that was the outline and it targeted, actually, I think we set that below and targeted outside, but you can also set it on the ground and target inside to like maybe build a pond. And, you know, you can go down to a particular spot, or you could, you know, choose your target as a specific elevation. So there's a number of different ways. So we'll use this surface file and we're going to go to the outside from this pad. And we'll use a ratio like we're going to use, say, a 3-to-1 side slope, or maybe 4-to-1. And these merged surface colors, yeah, I don't really need any of that, but it doesn't hurt to leave them there. And I'm going to, boy, they've added a lot of options to this command in the last several times. But what I want to do is, see, one of the things I can do is I can use different slopes for different sides, like That could be a 3-to-1. This could be a 2-to-1. But just to keeping it simple, I'm going to do that here. Notice you can calculate the volumes, do all this stuff in one step, but I'm not going to. I'm just going to leave it alone. I'm going to create the geometry, verify it, and then I would create the surfaces independently from that. Okay. You can even use a slope pad design where you can give it a cross slope so that right now it's level, but you tilt it and you give it a direction of a slope. So if you needed to drain this area, for instance, you could give it a nice, a little 2% bottom slope if you did it that way. But right now we'll do that. And I'm going to uncheck this calculate the pad surface because we could do that because we know how to build a surface. I'll do that all together. And then finally, I will draw the side slope polylines. I will color them. And in this case, blue is going to be fill and red's going to be cut. And I'm going to space them apart every 5 feet. And I'm going to use a corner delta angle as it sweeps around the corner. Those side slope lines are going to swing 10 degrees as it goes around that corner. Shrink and swell factors, subgrade and topsoil depths, all of those things, if you want, you can establish minimum cuts and fill heights. You can trim any contours that's inside that pad outline. Again, I'm not going to do any of that. And then finally, the pad layer, I'm just going to call that pad. I think that's what pad. Okay. And that's all I need. I'm going to say, okay. And now it says, okay, pick the pad polyline. Right here it is. Now, select the slope target surface. See, it says up here at the top line. So there's what I'm going to be targeting. And now it says, what outslope ratio are you looking for? Well, let's go to a 4-to-1. And that's for fill and cut. Well, let's keep them both 4-to-1. And now it goes ahead and it draws the shape of this. And you can see, remember I set the elevation at 99.5? So that's where my fill begins and that's where my cut begins up in this direction. Cut is red, fill is blue. So that would be what that would look like if I were to construct this. It asks you, do you want to adjust any of those and redesign the pad? Well, and if you did, you just step back through the same answers. I'm going to say no. Okay. And so now it's done. And the only thing I've done, I did not make a surface. I did not do any of that. So the only thing I did, I'm going to isolate this layer. The only thing in the world that I did was to create the geometry that would build that pad. And I used that to visualize and see where things are. And if I'm happy with it, then I'm going to build a new surface out of that. Notice I can use that as my inclusion boundary. Okay, so everything is ready to go. And all of that stuff is at elevation. So that would be one thing that I could do. I'm going to restore my layers. All right, so now I'm going to switch over to Civil for just a minute to show you one of the tools in there for those of you who have Civil that is very handy. It's also on the Surface menu, and it's related to this design pad template, and it's called Edit the Pad Template. So if I choose that, it wants me to pick the pad polyline, I'll pick it here, and I get this little box up here. So it reads that structure and says, okay, here you had a 4-to-1, 4-to-1 cut and fill. Your elevation is at 399.5. Well, there's a number of things you can do. You can change the elevation. Let's make that 398.75. Okay. Now, nothing happens yet until I hit process. And you see what I did there, and it shrank the fill and raised the cut. And it tells me the volume by report. See, it gives me the top elevation. Here's my earthwork volumes. I've got 232 yards of cut and 62 yards of fill. So on balance, I have to take away, I have to export. I'm sorry, yeah. I have to export 169 cubic yards or 4,575 cubic feet of excavation. Well, what if you said, well, I don't want to have to haul anything. I don't want to bring anything in. So I could use this balance button over here and choose balance. And I could say, leave everything. If import and export is zeros, I'll say okay. And now it's changed to this elevation, 399.8382, because that's where it gets me to a balanced condition within 10 cubic yards, which was what I did. When I told it to process. So you see my cut is 140, my fill is 146, 47. Again, use my report. Oh, I got to process first. Now I can report. And so now 143.02, 146.55. So, you know, you can set the amount of tolerance that you want to do for that. So that set it to balance. You can also do something like this. You can edit that. You can move the pad. So I'm going to go from here and just slide it down this way a little bit and then process. So now it jumped back over, recalculated the cut and fill. And now you see it's way out of balance again. So if I hit balance, let's cut this down to say within 5 and say, okay. And now you see what it did is it had to lower the top of it. But now I'm at 138, 138 as an elevation, and that's a balanced condition. Now, if I change the elevation, so that's 398, that's 395. I'm going to make this 390. So it's completely under the ground. So 390 as my elevation. Process. All right, so it's now completely in cut, right? In fact, that looks kind of cool. Let's take a look at it in my 3D viewer. So that would look like that. Okay, so in fact, let's not even do, let's make it 385, and let's steepen up the sides to 2.5 to 1. All right, and so now I've got 3,342.9 cubic yards of material that is required. You see how it would be that if I were to place that at 385 and dig it with those side slopes, I would get 3,342.9 cubic yards. Now, here's the nice thing about, let me get back to this top. Here's the nice thing about this command, this editing command, is, all right, that's well and good. That's going to be where my borrow area is. So I'm going to choose to balance again. Now remember, balance does not mean always make it 0 and 0. Let's say it's going to be a borrow pit for me. So I want to be able to have some export. So additional cut, I'm going to take away. And let's say I need, say 5,000. Well, let's go to 7,500. I need 7,500 yards of material. Right now, if you look at my report over here, I've got 3343 of cut, but I really want 7,500. So if I say, okay, now you're going to watch what happens is it's going to try several different cases, which it did, and almost, well, it didn't go off the edge. That was nice. All right, so that gives me 7,500.0 cubic yards, but it puts the elevation all the way down to 377.5. So if I needed this as a borrow pit, you see what I would have to do is go in there and start digging. All right, and you can obviously do this, you know, a number of different ways. Let's put these back. I'm going to go to threes, and I'm going to go to 399.5 and process and balance. And now balance. And I'll leave this one to be fairly balanced. All right, so there it is. Yeah, 120-ish yards cut versus fill. All right, so that's a nice little balanced pad, and that's how that one works. Again, you can move it, rotate it, change the shape of it, and just hit the reprocess, and it takes care of all that for you. You can now write the 10, and it will create that as a surface file. Okay. So I'm going to exit this, however. Oh, wait a minute. No, I'm going to do one more thing. Yeah, I'm going to exit this and go back to my top. I'm going to get rid of these here. And I'm going to erase by layer from the screen. I'll get that pad layer. So that's now that. Now let's talk about using a sloped top for a minute. I'm going to draw another pad, and I'm doing it this time, just draw a rectangle. And I'm going to say from here to, say, here. I will rotate that, sort of line it up, sort of near the site-ish. And I'll bring it into, say, right in. May have to get a little bit closer like that. Okay. And let's say that's 499.98. All right, so I'm going to do another pad design here. Let's go back to survey. And I'm going to go to surface, design pad template. And this time I'll leave everything just like I had it, but I'm going to come down here at the about midway down. It says use a slope pad design. So I'm going to do that. And I'm going to give this a 2% slope. Now let's make it 2.5. So that it will drain, but not be too steep. And everything else I'll keep the same. I'll say, okay. And it says pick the pad polyline. So I pick the pad polyline. Sounds like I'm picking a peck of pickled peppers. And there's my target surface, my out slope ratios of 3s. And now, because I'm using this as a pad design with a slope, it doesn't know what elevation to set it and how to set it. So what it does, it asks me to give it a bottom elevation, the lowest elevation that I want to use. But it also tells me on the line above that the range of existing elevations along the footprint range from 394.88 to 404.08. So if I wanted it to be all fill or all cut, you can see what you could do there. But I'm going to choose about a mid-range in between those. So it's about 10 feet, so 399-ish. So let's go with the 398.75 again, just for yucks. Now, obviously, you would have numbers and know them as to why you need them to be what they are. Okay, so there it is. Now it wants to pick the first point to define the slope direction. So I want this to, see, I've got a hilltop here and it drains this way and that way. Let's tilt it from this corner to this corner. Okay, so there it is. I'll say no. And that's now ready to be built. And it would be and fill over here and then cut a little bit here. And if I look at this 3D polyline, I can see this. I'll hover and grip and I'll look down the bottom. That's got an elevation of 399.41. This has an elevation of 398.75. That is an elevation in this corner of 401.35 and over here up to 400.70. So you can see this is my high corner and it goes down from that corner to that corner. Okay. So what time is it getting to be here? It's a good, tell you what, this is a good place to take a little quick break. Let's just take till the 30 minutes marker. And then we'll come back and finish up a couple of other nice little tools to know on getting this, some of this design done. Okay, so I'll see you guys back at 3:30. Any questions so far? Everybody good? All right. I will stop the share. And I'll pause the recording. Recording. Wow. Okay, so you've seen a couple things. Now, all I've done, again, with that routine is just to create the 3D line work, the 3D edges, okay? So how do I, what do I do with that? So I'm going to need to build another surface out of that information, okay? And then we can compute the volume that it takes, which we saw before when we were doing those edits, the cut and fill volume, that kind of stuff. And then you can also tie it in to this and have a bit of a grading plan. We can draw proposed contours, all those kinds of things. So the first thing to do to be able to model that information is let's isolate the things that are on that layer. And that layer was called pad. So let's go to the view menu and let's choose isolate layers. And let's just come in here and click one of those sidelines. That's all we need to do. And that now has, which I'm going to verify here in my viewer, the proper orientation and nothing goofy about it. I don't have any giant table legs dropping down to, some 0 or something. So that's good to go for a surface. I have along its edge, I have this 3D polyline. Remember, we're going to use that as our boundary so that we don't compute these long skinny triangles in these in-cut parts. And we will create that as a new separate surface. Okay. So let's do that. Let's go to the surface menu and choose triangulate and contour. Now again, I'm not going to draw the contours at this point yet, but I'll just triangulate. I'm going to check on to write the triangulation file. I'm going to check the file, and this time I'm just going to call it pad. And I will check to use the inclusion and exclusion areas because I have it there. And that's really all I need. I'll say, okay. And I'm going to select, I read my prompt, the line above, the inclusion perimeter polyline. So there's my inclusion perimeter. I'm finished selecting inclusion, so I hit enter to finish. Selecting the exclusion polylines, I don't have any. I'm going to hit enter to finish that. And now select everything you want to make a surface out of, and there it goes. Now I've got a couple of issues here, I see. I've got 5 vertical edges. Oh, look at there. They're 400 feet. Out of verticality now. What happened there, I wonder? It's probably all that editing that I've been doing. Let's see if I can find it. It never showed up in my, I know what happened. It said ignore 0, but look at this. Remember when I was doing the edits in the civil module? If I'm in top, I'm looking straight down on it. Down there's that original shape drawn down at 0 elevation. Okay. So that's what gave me that weird thing. Now I can either erase that, or when I go back to surface, triangulate and contour, I'm going to build it again. Apparently, when I did this, I had unchecked ignore 0. So you want to make sure that's on. And now when I say okay, yes, it's okay to overwrite. I'm going to grab the boundary. No more boundaries, no exclusions. Try this once again. My boundary, no exclusions. And now, get all of it. Okay, now no errors. Even though I still have way down here at 0, and I don't need it. I'll just select it and delete it. But you see the power and the value of that switch to ignore 0 elevations. Otherwise, it tried to make a surface that dropped way down there to those corners at 0 from 400 feet. That'd be a huge surface. All right. So now let's view that surface to see what it looks like. So I'm now going to go back to my 3D view. It's on the view menu, 3D views, surface viewer, and I'm going to view my surface called pad. I'll open that up, and there it is. Now remember, we had that little 3% cross slope so that it starts high in the corner and it drains down this direction. So it's actually about that's 2 feet, maybe 2.5 feet difference corner to corner. Okay. So not too shabby. There's all my little triangles. And if we add to that, I'll go to my model tab and I'm going to add the SP top. That's how that would get built. You see where it sticks through the top is where it isn't fill, where it's tucked underneath. That's how much we have to cut to get rid of it. Okay. And we could obviously, take that into an account to balance it, do whatever. But we put it up a little bit high here because we're going to shed the water down here. We don't want to shed it into a hole in that case this corner down here was too low. All right. So now let's do some work on things here. If I've got this as a pad polyline, that's my 3D polyline. I may want to draw, actually, I'm going to draw a 2D polyline. Let me see, that's my pad. Let's draw a 2D polyline. So draw 2D polyline. I could have kept the one I just threw away, but I'll just go back to this. A 2D polyline, I'm going to draw it. I'm going to uncheck this, use current drawing properties. I'm also going to uncheck autocorrect for 90-degree corners, just so I don't, I'm not going to have that sneak up on me if I don't need it. And now where it says layer, I'm going to call it 2D dash add. Okay, so now where do I want to go? I'm just going to hover over this endpoint, get one corner. I'm going to go to the other corner, get that corner. I'm basically just tracing over it. And the reason I'm doing that is so that I can change that. And now I'm ready to type C to close. And it's on a different layer. So I can now turn off this pad layer. I can freeze that and get it out of my way. I'm going to also change the layer of this from pad to a layer called pad boundary. which I have to make this time. There's a 2D pad, there's pad. So I'm going to make pad dash BDY. And I'm going to, that's actually, instead of just changing it, I'm going to go to edit, copy, copy to layer. So I'll choose that item to copy, and I'm going to copy it to the layer called pad boundary. Okay, so it's now there, and I'm going to now freeze that layer. So I'll go to my view, freeze layer by pick. I'll get one of these little side slopes. So now pad is frozen. I've got the two outlined shapes. I'm going to turn on, let's go back and do a layer restore from when I isolated. You know what I did? I erased all of my contours because here's what happened. When I went to create this new surface, under my surface menu, triangulate and contour, I forgot to check this little thing that says erase previous contour entities. I still had it sitting here. I said, yep, take all of them out. And I should have left that off and fixed it. Oops. Okay. But if we goes, oh no, where did those go? I lost my contours. No, you haven't. You still have the file. So you could go to surface, contour from tin file, choose that SP top, leave all those like you've had it. Everything's good to go. Erase previous. Now I'm going to set that to off so it doesn't erase them next time, because we're going to draw another set of contours here in a minute. And I'm going to say, okay. And what happened? Something got reset. Let's see here. Repeat contours from tin file. Top contour. Something reset all those. Okay, no problem. Say okay. No need, no need. All right, there they are. Now I will also do the old contour utilities, move the labels along the contours, put this guy up, oh, say here. And this guy we'll put over there. And we'll run this guy a little further up the street here just to get it out of the way. Okay. Now let's change. Let's see. I've got this 2D pad and I've got this pad boundary just so we can keep track of those visually a little better. I'm going to change my 2D pad to be this cyan color and my pad boundary to be, say, this magenta color. All right, so that's just there so I can keep track of them separately, visually. All right, so what do we do? We've got another surface that we've created. I haven't drawn any contours for it yet, have I? So let's go to the surface menu and let's contour from tin file. So we'll leave everything like we had it, but I'm going to choose my pad as my surface. But this time I'm going to, I don't need this on anymore for that. It can just go to the edges. But I'm going to turn off my labels. I don't need that because they're going to tie into my other ones. And for my layers, I'm going to put these on FG contour INT and FG contour IDX. No smoothing, same interval, everything ready to go. Hit OK, boom, there they are. Now it's a bit of a mess. I can't really see, what they look like but there's a number of things that we can do here. And one of them is we can change the layer or the color and line weights of those two FGs that we have. So here's my FG index, and I'm going to make it a fairly well, I'll just make it all black. So it'll be white on the black screen, and my intermediates the same way. And I'm going to give them a different weight. My index ones, I'm going to make them say 0.4, and my intermediates, I'll make 0.25. Okay, the 0.4 might be, yeah, that'll be good enough. All right. So now, if I do that, you can see I've got this big heavy contour and this little contour here, and they're a different state. But now I need to change these other ones just to make it a little less confusing. So my EG index, instead of red, I'm going to make it, oh, say this shade of gray, like 251. And the intermediates, I'll make a little bit lighter here at say 253. And not only that, I'm going to change their line style because there's all continuous. So if I want to change that, I'm coming over here on my index contours. I'm going to choose that continuous button, and I could add some of these things. Well, I don't have near enough. I need to put some more line styles in my bag of line styles that I can choose from. Okay. So there's a button down here that says load, and everything I'm doing now, everything I'm doing here is all just pure CAD. It has nothing to do with Carlson. So I'm going to load from a particular file. And right now there's a file that's pointed to here called carlson.lin. It's a line type file that Carlson provided. And it's got all of these different line styles. And you can see there, and there's little previews. There's a fence, there's a center line. There's, proposed sewers and gas lines, et cetera, et cetera. One of the ones that I'm looking for is actually called contour. Now, it's not in this file. See, there's communications lines, et cetera. So I'm going to go look in a different LIN file, and I'm going to go up here to this top button that says Browse, and it's going to put me out here in this area of my computer, this all I want to do is change that. There we go. This folder, that's what I'm trying to think of the word. So it puts me in the support directory of where these line styles are installed. And they can live anywhere, but that's where they go by default. And I'm going to, instead of using Carlson's, I'm going to choose this icad.lin. And now there's C and G line definitions. I mean, I've got literally hundreds of these different line type files scattered all over the place, and they can come from anywhere. And so now, here's a bunch of these, and they're all these different, what are called ISO patterns, International Standards Organizations. And you can see they've got the entire alphabet in every digit, so it would be, if you want to make a water line, you just choose the W, et cetera, et cetera. But I'm going to go here and I'm going to look for this one here called Contour and Contour 2. So there's Contour and Contour 2. Now, what I'm doing when I hit load, I can load any number of these in here. So I could take that one, take those, and then go down here and find, I don't have a barbed wire. I didn't. anyway, you can load up however many you want to do. I'll just keep those two to keep it simple. I'll say, okay. So now I've put that in my list of line styles to choose from. And so I'm doing the index layer. I want that to be the longer dashes. So I'm going to choose that one. And the intermediate, I'm going to choose to be the shorter dashes, this contour 2. I'll say, okay, all right, everything's good to go. And there you can see the dashes show up, but I have to get really close to make them show up. Why is that? Well, there's a couple of variables that you need to be aware of and to make sure that you're using correctly. And this is a limitation of AutoCAD and therefore of IntelliCAD, because IntelliCAD is a clone of AutoCAD. It has to work the same way AutoCAD does. So when AutoCAD makes a limitation, IntelliCAD has to follow suit. So what that is they don't really do a good job of scaling their line types very well. And there are several variables that control this. There's one called LT scale, and that is a line type scale. Hold on a second, I've got something on my keyboard here. Okay. It's called LT scale, okay? And right now it's set, mine is set to 1. But Carlson does, for whatever reason, in some old legacy things, when you go to settings and you go to drawing setup and you change these numbers, it put the multiplier down here. And I need to leave that as 1. The way I do my work, you won't necessarily notice it unless you're, if you do these other 2 variables that are different. But there's a thing called MS, excuse me, MS LT scale and PS LT scale. And that stands for model space line type scaling and paper space line type scaling. And Carlson's insistence on changing that overall global line type scale comes from the fact that they usually work with the model space scaling turned off. But we need it to be on to handle some of these other line styles. So here's what we're going to do. We're going to type MSLT, and that word MSLT scale comes up. I hit enter, and I'm going to turn it on instead of off. I'm going to type PSLT scale until that comes up, and I'm going to turn it on. It is already on. Okay. And now I'm going to type LT scale. That's the global line type scale. And I'm going to make sure it's 1. And now when that's done, I'm going to type REA to regen all. So now there it is. Everything is regenerated. My dashes are still pretty tiny here for this. So if I look at that, let's get a 2 samples and test this out a little bit. I've got these things here at that particular line scale. There's something wrong. Let's see, MS scale. Let's turn it off. We'll do, oops, REA. MSLT scale on. It's not regenerating. Regen. Oh. Oh. Okay, let me pop over here, pop back. Maybe so. All right, so I'm going to take these 2 lines and I'm going to come up here to my line type scaling and I'm going to make them 5 times bigger, and that's about what I want. So yeah, so if I take these 2 and right click and choose select similar, it's going to find all of those. And I'll come over here to my line type scale and type 5. And there we have it. So it looks like some dashed lines, whereas our design contours are bold and continuous. And you can see how they tie in. If I were to review, show hide, hide by selection. If I turn off this footprint line, now you can see how those contours wrap around the edges and they tie right into those other contours. Okay, you see how that worked out mathematically? I used to work with a guy years ago. We worked on landfills, and he would do things like that. He was a drafter. It was an older well, older at the time. I was a kid. I was in my 20s. I'm in my 60s now, but he was 40 something. So, but he was an old school drafter on a drafting table using an ink pen. And so what he would do when we would draw these contours like this, he would go through and he would erase a little snippet off the end of each one, and he would draw in a little arc. You know, from here to say here, and then I can get this thing to behave itself. Say here, and then he would trim off, you know, that drawing. So all of these little contours that tied in, he would make look really nice and pleasant. It was a very nice looking drawing. But now you can imagine, we were designing 6,000 acre landfills. There's a lot of contour lines in there, and he would go and do that to the ends of every single one of those lines. All right, but anyway, we've got a little bit of some stylistic distinction between our two sets of contours, so we can use that to create a grading plan. And we would make that grading plan to be, you know, we show the existing, and we would go over here in our layout space, and, you know, we would, you know, see, that's what. Yeah, there's something going. All right, so that's going to make it work there this time. But so we would, you know, come over here and show these in a different set of colors, and maybe these heavier, different styles, that sort of thing, to indicate the existing contours. And now here's our design contours that are going to tie into it. Another thing that we could also do in that situation, remember our command. Let's see, I'm going to draw, not draw, sorry, view, show hide. I'm going to show all, so I'm going to get back my perimeter. Remember, we did that erase by interior, erase by closed polyline, or you could even break by closed polyline. And if you take that boundary and clean out all of the interior lines, all of the existing contours, then you would see the resulting final contour, even if they're in different styles. But so you could do it that way and get rid of them, or we could even do this. If we just simply redraw, we're going to erase all of the existing contours. So I'm going to erase by layer. So edit, erase by layer. Clear that because I want to keep what's on pad, but I want to select from screen, and I'm going to get one each of those two existing contours. Come back and say, okay, so they're now gone. Now, when we draw the contours again for that layer, so I'm going to go back to surface, contour from tin file. I'm going to choose that surface. That was my SP top. And I'm going to double check my layers now. Instead of FG, I'm going to choose EG back again like I had it. Again, I could have saved the settings and just reloaded them. I'll go back to label. There's EG again, EG again. That's all well and good. Beep, beep, beep. Now on the triangulate tab this time, I'm going to say use inclusion, exclusion areas. I'm going to say okay. And it says now select the inclusion. I can either ignore it or I could have chosen that outside boundary. And now it says select the exclusion. So I'm going to choose that purple polyline there as my exclusion and hit enter. And voila, off it goes. Now, if I show hide by selection and I turn that little guy off, and let's do one more. Let's turn the pad off itself. So there now you can see proposed contours meeting up with existing contours, but we've effectively trimmed out the things in between. But we haven't erased the data. We haven't gotten rid of the surface that's underneath there. All we did was just draw the contours up to that bounding box. Okay. So what else could we do with this information, with this pad that we've now done? If we needed to compute the volumes to build that pad, how would we do that? Well, I'll have you guys step through it. I'll talk you through it, but I want you to think about it. How would we compute the volume to go from that existing ground, the SP top, to this pad platform? And that would be, first of all, which menu do you think we'd look under? Since it's dealing with surfaces, let's try that menu. And then let's sort of look at what we're, okay, there's our volumes by triangulation. And we've got two surfaces now that we're interested in. So two triangulation surface volumes. Read the top stripe, select the existing surface file. That's my SP top. Now select the final file. That is my pad. No inclusions or exclusions I need to worry about, because it will honor the boundaries of there's no data out there for it to get confused with, so I don't need to trim it off. I'm going to uncheck my tonnage reports and I'm just going to say, okay, here's now that report, and I can print it or do anything I want to with it. So I've got 89 yards of cut, 553 yards of fill. I would, if I wanted to, I could drop the elevation of that pad by 1.5 feet or so and get closer to reaching balance. But maybe I've got some other site constraint that made it be that elevation. No big deal. There's, like I said, 500 yards of cut, 3,100 yards of fill. I'm sorry. Divided by acres. No, those are my cut and fill ratios. I've got up here is my volume, the actual 89 yards versus 553. Whereas this is your cut in cubic yards divided by your area in acres. So that's how many cubic yards per acre is going to work out for those. And this tells you where the maximum amount of cut occurs. There's 4.004 feet at this location. The maximum fill is 5.8 feet at this location. Okay. So all kinds of information, and that's how you do that calculation and how you work on it. Now, what if I needed to say, put a ditch into this pad? So yes, it does slope down, but let's say maybe I wanted to build a ditch from here and it goes all the way down here to this bottom area. Well, we're going to now draw. I'm going to switch over and I'll go ahead and switch to a layer. I'm going to make a new layer called ditch. And let's make it cyan, I guess also is fine. I'll make it current. And I'm going to draw a 3D polyline. And I'll check on to use the current drawing properties. And if I want to just use a surface model instead of prompting for the elevations all the time, I'm going to turn that on right here. Okay. So when I click, 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 as long as I'm on that surface, it's going to read the elevation of that surface where I click it. Okay. So I'm going to say, okay. And I'm going to use my pad as my surface. Now it reads that elevation as I'm going along. So I'm going to start right here, and that's going to be an elevation of 401.13. Okay. And now as I go along this way, you see it's reading the slope. There's that 2.5% side slope or cross slope that we put on there. So I'm going to come all the way down here, but I'm going to actually go a little further. I'm going to come down the bank. And that's now going to make that at a 3.2% slope. So it's slightly below. It starts out up here on top, but then it's slightly below. Now, how do we actually construct this as a ditch? Well, let's see. Let me turn back on. I wanted to make sure I did not get off the edge of that. So I'm going to actually go from there. I'll go all the way down here to the exact corner. Yeah. All right. So now I've gone from that elevation, and up here I'm actually sitting right on top of the ground because I used that in my prompt. If I want to verify some things, I'll go to my inquiry menu and I'm going to choose my drawing inspector. I'm going to right click and make sure I'm going to turn the elevation off, but I'm going to display the polyline data and maybe even the direction to make sure that I drew it correctly. And so now as I hover there, you see that's the direction it's going, and that's going to correspond to the report that says my slope is negative 3.41%. Okay. So that's going to be the basis of my ditch. I'll right click and turn off my drawing inspector. And we're going to now design this ditch and build it into that pad surface. But right now it's just a 3D polyline, just like we did the pad before. So, but we're going to use all of this geometry to help us construct this ditch. So I'm right now again, starting at the top of the ground up there in the upper corner, but it's going to get deeper and deeper as it goes down toward the corner because I jumped all the way down to that bottom. So it's a foot maybe or half a foot or so lower at that place, but I have a 3D line. So I'm going to use the same command called design pad template, just like we did on the building pad, except this time it won't be a closed polyline. It's going to be a single line, and it's going to go out and seek the existing ground, or it's going to seek a surface, whichever surface we tell it to seek, which will be that pad surface. So let's do this. We're going to take this. This could be the center line of the ditch, or it could be an edge. We'll take it the center line, but so I want to make my ditch to be 2 feet wide at the bottom. Okay. So there's a CAD command. If I'm using flat 2D polylines, I could just run an offset, but I can't offset a 3D polyline because of limitations in AutoCAD and IntelliCAD. It just won't let you do that. So we have to offset it, but using a 3D offset that Carlson wrote the command for. So that's going to be under our edit, 3D polyline utilities, and this is where we offset our 3D polyline. Okay, so we got several ways to offset a polyline. We can take these different methods. We can go by interval, and that's what we're going to be doing most of the time. And we would say, let's use this interval, and we say, okay. And we read the prompts, and it says, what is your horizontal offset amount? All right, I'm going to go, I wanted a 2 foot wide ditch. I want to make it 1 foot, or I'm sorry, 2 feet horizontally. Okay. And now it wants to know a vertical offset amount, but notice I've also got the ability to choose that as percent and degrees and ratios, but a vertical offset amount. So I'm going to say 0. So it's just going to go from there 2 feet over, and those are exactly at the same elevations. They start high and they go low at the same spot. Now I'm going to sort of trim this back just a little bit. See if this will work. I'm getting too close to the edge of my surface when I do the rest of this work. So I'm just going to cut it back a little bit. All right, so I now have these 2 lines. They're drawn in there, and if I look at this in 3D, I'm going to go ahead and look at that and that and that, and maybe that one and that one. So I'm going to select all of those, and I'm going to go to View, 3D View, Drawing Viewer, and let's see if I can get a sense of what that's going to look like. No, still good. All right, let's ignore the 0. So you can see right up here, I'm sitting right there, right there at the top of that surface. And if I go down here and I see I'm actually I'm a good bit underneath it. So that's what I wanted. I wanted my ditch to get deeper as it went downhill. I can even verify to add my pad surface in there. And I see that indeed it's lower down there, but it pokes up out of the ground up here in the top, or up to the ground. Okay, so good verification on all of that. We've got the edges of the bottom of my ditch. So how do I get the edge of where it's going to jump up and catch this surface up here? Same thing with this. And we do it a number of ways. If you go back to that same command, edit 3D polyline utilities, offset 3D polyline, I could choose surface and say, okay. And rounding the exterior corners, yeah, but we don't have any. The slope format, I'm going to choose a ratio. And I'm just going to make this I'm going to choose this. I'm going to target my pad surface, and the ratio I'm going to go with, say, 2-to-1 side slopes. And I'm going to go to that side. Okay, so what happens now is that this gets offset up to the surface. Now remember, this line here was on the surface, so it offset to wherever this other line at a 2-to-1 side slope would intercept and landed on the surface. But now what I would have to do to build that as a surface is select that and do the other side, etc. Okay, so that's sort of the way we can do it, but I'm going to go back and do it again because it helps me visualize. I'm going to do using that same on the surface menu design pad template. So I don't need to offset the polyline. The polyline's there, but I'm going to use it as an edge to do this design pad template. I'm going to target a surface. I'm going to uncheck this slope pad polyline because I'm not pitching the pad. It's already got slope on it. And I'm going to change its pad layer to, I'm going to call that ditch dash 3D, just because it's going to generate my work. I'm going to say, okay. And it says, pick the pad polyline. Well, here, pick the surface. Excuse me, that's my pad. 2-to-1, 2-to-1. Pick the side, because now it's not closed like the building pad was, where we told it in the dialog box to go either outside or inside. This is actually now an edge, and it needs to know which side do you want to project. Well, let's go to there, right? So now I can see that pretty well. Do I want to adjust and redesign? Nope. I'll just repeat the command. I'll get the other side. And this time maybe I'll just leave everything like it is. But this time, instead of doing 2-to-1, let's see, maybe we're going to go with 3-to-1. Make it a little less steep. And I'll pick on this side. Okay, so I'm going to have one edge of my ditch laid back a little flatter than the other edge, but not by much. So this is what it's going to look like. And let's just take a gander at everything. In my 3D viewer. So are you getting the idea that I really like that 3D viewer? So that's going to be, once I build that ditch, it's going to effectively drain that building pad. Okay. Now, think about this a little bit too. When you're doing things like this, let's say I've got, say maybe this is a parking lot. And so I'm going to just design the edges, give the four corners of the elevation, but let's say I needed to crown the middle, or if I needed to put a little swale down the middle of my surface. So what I would do simply is to go to that, once I would save the surface, and I would draw another 3D polyline. And I would make sure I said, use a surface model from the file. Okay. So when I draw it, it draws it and lays it right on that surface. And then I would I would select that drawn element, and I would just simply I would raise it or lower it on the Z-axis. I can't change its elevation because it's got a changing elevation, but I can go to Edit, Change Elevations, and this time, instead of making it absolute, which is what the properties does, I would make it differential, and I would you can change this layer, do whatever you want, but when it asks for the difference in elevation, I would put in, say, -2 or minus, if I wanted to make it up off or down below that surface. But if I'm doing a parking lot and I'm drawing a curb island, I might just draw the whole thing, and then in 3D, I would have it to drape on that surface, and I would draw those islands. And then I'd have a 3D edge. In fact, instead of sitting here talking about it, let's just do it. If I draw a 3D polyline, and we'll just keep everything the same. We're going to go to pad. I'm going to go from here to here. And I'm going to do an arc, just the arc around here. It wants me to do an endpoint, let's say here. And I want to be parallel to that edge over there. So I'm going to hold the shift key and right click and choose my parallel snap. So I'll hover over here until I see the word parallel. And now when I go here, it's going to snap. So I'm going to go down to here. I'm going to say arc again. And let's see, there we go. I want it to be. Like so. And then I would, let's just simply close it. It's not closed. We'll close it. All right. So now we've laid this outline directly on the surface of that path. And we're going to be using that as a curb, a little island, a parking lot island in our parking lot. I didn't have to know what the elevations were, do anything else there. I just let the surface control it. Now I'm going to go to my edit menu in my 3D polyline utilities, and let's offset that 3D polyline. And I'm going to do interval again. And I'm going to say, okay, so the horizontal offset amount. Now what I'm going to do, if that's a curb, I'm going to build an island out of it. So I'm going to want to raise up the top of the curb and then the back of the curb. And the tops of the curbs are, usually they're vertical. But remember, you can't have a vertical face in a triangulated surface. So I need to give it just a little bit of a lean back away from the vertical. So my horizontal offset amount is, I'm going to make it 0.05, just half of a tenth. And what's my vertical offset amount? Well, that's going to be 0.5. That's going to be a 6-inch curb. So I'll say that. Now I'll pick a polyline to offset. I'm going to pick this one. Which side to offset? I'm going to go to the inside because that's my leaning direction. So I now have basically the top of the curb that's 6 inches higher than the bottom of the curb, but it's half of a tenth on the inside because I can't have that vertical face. And I can't have an overhang, so I can't go out the other direction. I'd have to, lean it back. I can't have something on the top that sticks out over its footprint. So now I'm going to repeat that command by interval again. And now the horizontal amount is going to be, I'm going to make that 0. What would normally be 0.5, but I already leaned back 0.05. So I'm going to say 0.45 just to make it all even Steven. And my vertical amount, I'm going to say 0. So I'm going to choose this to that. So that's now the top of my curb. All right. and I'm going to do a little trick here next. I'm going to draw a 3D polyline now from here over to here. And again, oops, I said 2D, I meant 3D. Draw 3D polyline. Oops, sorry, draw 3D polyline. I'm going to uncheck this surface model because I'm going to just snag the geometry. So I'm going to now go from here to here. I'll repeat that command and go from the other ends. You'll see why I'm doing this in just a minute. So now I've gone from the edge to the edge. It's all flat across there, but I'm going to now draw this 3D polyline one more time. Whoops, sorry. I'm going to draw the 3D polyline one more time, and I'm going to snap to the midpoint and go to the midpoint, but I want it to be just 2/10 or, or maybe a 1/10 and a half higher than that flat ground because I'm going to mound up the soil in this little island, okay? So instead of, I'll turn on this prompt for elevation and I'll just confirm it, but I want to add right here a 0 point. Let's do 2/10. We'll make it 2/10 higher across the crown of this thing. I'll say, okay. I'll now snap to the midpoint, read my prompts. It says, so it read the elevation there and it did the elevation adder of 0.2, and it wants me to now confirm this would be 0.2 taller. I'll say, okay. And I'm going to now go to this midpoint and it wants the same thing. What's the elevation there with the adder? I'll say, okay, enter, and I'll hit enter to finish. Now I no longer need these. And what do I have? Let's take a quick peek. I'll take those. I'll take that polyline, I think is, no, that's a 0. I've got the 3D version, but it's on that frozen layer with all the side slopes on it. So anyway, I'll just take this and do a view. And you can see there's my curb. And it lays on that surface, which I can verify by going to my model tab and adding that pad surface. So there it is, right there where we expected it to be. Okay. All right, so now what do we do with this pad and with those things? Well, here's the last kind of cool trick. All right. Let's build a surface out of this. So I'm going to go to Surface, Triangulate and Contour, and I'm going to write the triangulation file. I'm going to select, and I'm going to call this Island, except ND. There we go. So Island. And now I don't need to use an exclusion areas because there's no in cutting thing. If I do it, it just automatically would be that way anyway, but I'll just keep it on just to get in the habit. So I'm going to use the inclusion, ignore zeros. I'm not going to contour anything there yet, okay? Which means no labels. I'll double check my selection, nothing's on. Everything's good to go. I'm even going to, let's densify these every 5 feet's fine. So I'll say, okay, I'm going to now come down here and choose that perimeter. And by the way, even though I said an arc, remember if it's 3D, it can't have arcs. It's got to have those little squared off edges, but they look round enough for that. So there's my inclusions, no exclusions. And now what do I want to use? Well, just that. All right, so now to take a peek at it. There's my island. And let's pop in the old pad to compare. And I'm still way exaggerated. Let's come back down here. There we go. There's a one-time exaggeration, but wow, look at that. A nice little rounded. You can see the bull nose as it came around the corner. So it mounded up this little island, put the contours around it, and the contours, see, they come straight across, and they dip down and come go across the face of that a little bit, and then it climbs back up. And the reason for that, by the way, is because there is, that's not sitting on flat ground. It's sitting on a surface that slopes from this corner down to that corner. But we very effectively just did this just by putting in the parking lot edges, making that was our pad. That's a surface. All right, so now we've built the island. Let's work on the ditch next and how are we going to put that into our file. So I'm going to go to my view menu and I'm going to isolate layers again, and I'm going to pick just the ditch. And I see that, in fact, there's nothing else there. So I'm going to make a surface out of these two pieces of things. Did we view this thing yet? I think maybe we did. Yeah, because I remember spinning it around. And there you can see, that one side is flatter than the other, doesn't lay back at the same steep angle. We're going to make a surface out of that. Now, what do we do with that? Well, I need a boundary, because if I don't, it's going to come in this gap in here and it's going to try to go in it. Now, it might be all right to have it without it, but I'm going to go ahead and choose one. I'm going to shrink wrap. So I'll go to draw, shrink wrap entities, and that'll be fine. I'll just drag all that around there and see, okay, that closed all of that up and went out there. That's perfect. All right. And it turned that back on because it used the same layer. So now I'm going to go to surface, triangulate and contour, choose the right triangulation file, choose select, and I'm going to make one now called ditch. I use the inclusion. I'm not going to contour it yet. I'm going to say okay. So here now is that inclusion polyline, no exclusions, what data to use. That right there. Off we go to the races. Let's look at that surface just to verify it. And there you can see is a ditch surface that starts up here high and gets deeper as it goes downhill. Okay, so what do we have so far? Let's turn everything back on. And let's freeze my. Okay, looks like we lost one of you. That's fine. So I'm going to freeze those points. Just get them out of the way. So now we've got several surfaces. We've got a bottom surface, we've got the stockpile surface, and we've got a ditch surface, we've got a pad surface, and we've got this island surface. So what can we do with all of those different things? We've already done the pad. We've got that drawn. contours drawn for that. So, but we've added some things to the pad. We no longer have the contours to go straight across. They're going to come down here and then they're going to climb up and go across and come back down and do that kind of stuff. So let's go to view, freeze layer by pick, and we'll just turn that little slanty thing off. We'll turn that thing off. And let's redo the pad. In fact, we'll go ahead and erase by layer. I'll clear that, select from the screen. I'll get the design contours. So they're now gone, and we'll recompute those here in just a minute. I'm also going to freeze this boundary and that line of the ditch. Okay. So we've got these three surfaces. I'm going to put them all together into a single surface, and I'm going to do that with my surface menu to do triangulation file utilities. I'm going to now load in the 10 file, and the one I want to use as my basis is this pad. So there it is. You can see, let's go back to land view. You can see how it would look. And I'm going to go over to the next button. Oops. I guess I could go to the next button instead of the exit button. All right, there's my pad. All right. And I'm going to go next. Let me open this up a little bigger so you can see it a little better. And we'll color that in. So spin it around. And now what I want to do to this is I want to merge one of those other surfaces into this surface. And I do that with these buttons over here, and you can see all kinds of things you can do, but let's do a merge. And we're going to take the default here. We're going to say the second 10 is inside, the current 10 is the outside boundary with the transition. And I'm not going to change the coloring of those triangles. Well, yeah, maybe I will, just to see it. So I'll say okay. And I'm going to add, first of all, the island. Okay, so there now is how that island would get merged into this pad. All right, that's great. I'm going to now merge 10 again, keeping those same things, and I'm going to choose my ditch. I choose open, and now you can see there's the result of my grading and of my design. And so all I need to do at this point is to just save this out as a new file. So I'm going to come down here and save as. Down at the bottom, I'm getting the insides and the border and the outsides. And I'm going to call this one my pad dash modified, let's call it. Okay, it's now saved. I'll exit. Now I can go out the door. I'll verify my view of this new file, pad modified, and double click that. And there now is my graded ditch. Now you could see I should probably have put an end cap on there, because right now when the water comes down there, it's just going to hit that little wall. All right, so I would have should have extended that on down to that bottom down there. So when I trimmed it back earlier, that was the wrong thing to have done. But you see, by being able to look at these things, you're going to be able to verify stuff. You're going to be able to know how to fix these kinds of things. So what I would do to fix this is really I would go back out to my design, and I would take that this bottom edge down here, and I would just draw that one 3D line, and then I would offset a 3D offset projected to this surface of, you know, maybe a 0% or a negative point or a negative 2% or something. So it comes out and it daylights. So it basically knocks that little end wall out of the ditch. And then I would just merge that in. Same thing, you know, I might need to think about, you know, trimming off those little corners up there because I've got something just slightly out of whack on the move around. All right. So now then, once all that's done, if we contour from tin file again this time, we're going to do the pad modified, and we'll leave everything else like it was, making sure we're going to draw on FG. And we're not going to label because they're going to tie. So FG, draw contours, contour-bindable. Everything's good to go. No need for the inclusions and exclusions. And say okay. And boom, there's your grading plan. And that's down at 0. So I'm just going to ignore that for right now. But when you're in plan view, it would certainly show up and you could label it. But notice those contours. Now, if any of you guys have ever done any design work, and if you're, you know, used to drawing contours to try to indicate what you're trying to do, I hope you're going to realize that this thing is way more efficient and, you know, at doing that kind of work than pencil and the paper is, no matter how fast you are in that regard. Okay. So that will be about it for today for the class. And if you come back over here, when you get a chance to work through this, the very similar type things that we're doing is we're putting in these pads, cutting the side slopes. The only thing we didn't get to was, and see, here's that merging of one into the other. And there's your contours, etc. But we did not get into this little centerline road design and a profile. So that would be a nice little thing to sort of grow into as you're going through these examples. All right. So they do everything that we just did. It just wraps everything all together. You know, don't try to do it all in 2 hours. Try to, you know, take a week to go through it and learn these concepts. Okay. Any questions at all? Anything like, you know, how are the Steelers doing? You know, one of these days, I keep telling people I'm going to grow up to be a Steeler, but I'm past retirement now. So anyway, all right. Like I said, keep my email handy. Any questions you have, stay in touch. We'll get back to that. Now I will, let me ask you three, I guess John already, was it John? Yeah, John's already gone. Are any of you guys either a PE or a PLS or PG, anything like that, that you have a registration?
No, none of the above.
Okay, for you, Jim. How about you, Cyrus and Jacob?
Yeah, I don't.
All right, Jacob.
Nope.
Okay. Only reason I ask is that to maintain your professional registration credentials, most states, in fact, I believe all 50, require you to attend a certain number of hours of continuing education every year or every 2 years. And you get credit for that for this class. And we issue a certificate and also keep everything on file. So you'll get those when I send out the links to the videos. You know, so we'll have that for you and keep those on record, but you may not need them. To you, it's just going to be a nice fancy placemat that you can set your burger and fries on when you get it. Although it will be a PDF certificate, so you'd have to print it first. But I also wanted to know if you had those designations, I would put that after your name on the certificate. So otherwise, you'll get it with have your name on it, have the date and the name of the class and all that good stuff. So if there are no more questions, we'll call it a day. If there are, ask away. I'm here for, answering any questions that you may have, or you might want to try to digest some of this. It's like getting a drink out of a fire hydrant. It sort of comes at you all at once. It might take a little time to think about. So everybody good, or anybody have any questions?
Nope, thanks for your time.
Thank you.
Okay.
Yeah, I'm good. Thank you.
Sounds
good one.
grand. All right, guys, I enjoyed it. I will issue out those certificates and links to the videos. You'll get an email within a couple of days. It might actually be the start of next week. There's not a lot for me to have to do, but I have to wait for the videos to finish processing and then get them up to YouTube. And I've got some other things that we're trying to get taken care of, this funeral, for instance, and it's coming tomorrow. And whichever two of you that it was in the original sign up, we talked about shifting the class. You didn't have any problem with that. I appreciate it. It's really helped out. So, all right. And with that, let me see. There was that was John. He sent me a chat and I missed it. He said, unfortunately, I have to leave right now. So thank you for everything. I'll be in the next class as well. Oh, great. All right. So, I think that was the last one, was it? Yeah. Yeah. Okay. All right. So I will, like I said, I'm going to go ahead and stop the recording at this point.